Welcome you all. Today, day six, Atal FDP. So, you know very well, today we have three session. So, first session, Dr. S. Karthikeyan, Assistant General Manager, Ashok Leyland, Chennai. And second section, Mr. Siv Subramanian, Calibration and Powertrain Engineering, AVL. And the third section is Dr. S. Prabhakaran, the Director of BTI Innovation, Bangalore. And after that, we have 6:30 to 7:30, we have test, and 7:30 to 8 o'clock, we have validity functions. Now, I request Dr. Zubair to give brief introduction about Dr. S. Karthikeyan, sir.
Thank you, Dr. Ilwalai. Good afternoon, all of you. I'm here to give a short brief information about our speaker, Dr. S. Karthikeyan. Dr. S. Karthikeyan is an accomplished automotive professional, 20 years of industrial experience in the advanced vehicle technologies. He currently serves as Assistant General Manager and Domain Head, Fuel Cell Product Development in the Department of Advanced Engineering at Ashoka Leyland Technical Center, Chennai. Academically, he holds BE Mechanical, MTech in Automobile Engineering, and PhD in Automobile Engineering from Anna University. Reflecting a strong blend of theoretical and applied expertise, his professional career includes a pioneering work in the fuel cell, electric vehicles, electric and hybrid vehicles, and development of the advanced emission after treatment system, such as a DOC, DPF, that contributing to significantly to BS4 and BS6 in the heavy duty trucks and buses. Dr. S. Karthikeyan has also played a key role in the launch and localization of critical automotive system for the leading OEM including Ashoka Leyland, Ford India, and held senior position at Nissan, Ashoka Leyland, Ford India, and ARI. He has an impressive research profile with more than 40 international journal publications and 5 patents in the fuel cell system. A recipient of several prestigious national and international awards for innovation and technical excellence, Dr. S. Karthikeyan is also an active member of SEI and ISME and serves on technical boards for reputed universities. His expertise span electric mobility, fuel cells, combustion improvement, thermal coating, and air induction system, making him a distinguished and highly respected expert speaker in the automotive and energy domain system. I request Dr. S. Karthikeyan, please take the session.
Thank you, sir. Thanks for the introduction. So, myself, Dr. Karthikeyan, heading this fuel cell division, and I'm just going to share with you the past 3 years journey on fuel cell. How we, the problem statement for this getting this new technology is CO2 emission. Normally, the CO2 emission from different sectors used to come, and because of the change in the life cycle or change in energy requirement, modernization, etc. So all these things create for a requirement for more energy. So in that case, the CO2 emissions from industry is 42, automobile is 22%, and I'm just showing left hand side. You can see from different sectors how many, how many, what is the percentage of CO2 coming in. And if we go more into the depth of automobile, we can see commercial vehicles around 34% of CO2, passenger car is emitting around 40%. So like that, the CO2 emission from different sectors keep on increasing day by day. In order to mitigate this and to go with a good energy source without CO2, this hydrogen fuel cell system plays a major role. And normally, this hydrogen fuel, if you take, it is developed through electrolysis process and different other processes also available. And getting the hydrogen fuel through this electrolysis process is called green hydrogen. If you take, on the left hand side, you can see on a barrel of hydrogen tanks are available, and in which the electrodes are placed. By passing the electricity, some sort of dissociation, the splitting of hydrogen and oxygen will take up. So through which hydrogen is generated, and the energy the current which is passing through this container is mainly from the solar or any other renewable energy form. So that is what we are saying. The energy developed for hydrogen is also green, and the hydrogen fuel is also having without CO2. Without carbon. So it is H2 only. And moreover, if you take the energy density of, the energy unit mass, if you take for hydrogen, it is around 120 megajoule per kg, which is 3 times than that of a gasoline. So that's why hydrogen plays a very key role in upcoming transportation sector. In the next slide, what I'm showing here, you can see hydrogen fuel production process. Normally, the hydrogen is developed either from natural gas or oil derivatives, coals, renewables, biomass, algae. So different types of algae, different types of systems are being followed up. Methodologies are followed up for getting this hydrogen, and what government is trying to take it up, more concentration is on the green hydrogen process through electrolysis. In this slide, what I'm showing is powertrain technology. On the left hand side, you can see IC engine, internal combustion engine, what currently available in the vehicles. And now in future, we are going to go with this fuel cell technology, and the entire powertrain will look like. So on the left hand side, you can see this IC engine. On the right hand side, what you are seeing is a fuel cell technology. This IC engine, the power from the IC engine will be around 80 kilowatt or 100 kilowatt, 45 kilowatt. So different types of power requirements are being used according to the different vehicle requirements or different vehicle power requirements. In similar way, the fuel cell also been designed to get similar power like 45 kilowatt or 80 kilowatt, 90 kilowatt, 120. So different ranges we can get in this type of fuel cell system also. The right hand side, what are you seeing is a pack of fuel cell system, high power fuel cell system. Now you're able to see a efficiency curve slide. So in case of efficiency curve, uh, the fuel cell plays a major role. It is on the topmost curve, around 50 to 55% of efficiency it is playing. And below that, it will be a diesel and gasoline. So depending upon the different power rates, these fuel cell efficiency will be keep on changing. On the right hand side, you can see the red color curve, which is on the top fuel cell curve, and the bottom, the blue one, it shows the internal combustion engine curve. After certain point of, if you see the fuel cell curve, after certain point, you can see there is a drop in the fuel cell curve also take up, depending, as we increase the power rate. So in that case, if you want to increase the fuel cell power, we will be going with the hybrid battery systems also. So battery power plus fuel cell power together, in order to get the power requirement of the motor, we will be matching both the energy levels, and we will be incorporating such type of design in the vehicle. On the bottom side, you can see in a passenger car how architecture of the fuel cell electric car looks like. So it contains whatever the main components. It contains a motor control unit, battery. You can see the green one battery is there, and to charge the battery, there is a charger, plug-in charger is there. Apart from that, there is also a fuel cell architecture, fuel cell engine. Fuel cell have to be controlled, so there will be a separate fuel cell controller. And the last part is on the hydrogen gas. Similar like diesel, how we are filling the tanks for the fuel. Here also we have to fill the hydrogen tank. So hydrogen tanks will be incorporated in the vehicle. So some key architectures, some of the key components used in this architectures looks like the below system. So now what you're seeing is hydrogen versus battery trucks, especially if you take a long haulage trucks. So where if you want to go for a higher mileage, for example, the fuel cell truck can give around 1,200 kilometer in one fueling, whereas a battery truck it will be giving around 800 kilometers of mileage, and the IC engine still it will be lower side than the battery. So like this architecture, why we have to go the fuel cell is because of the higher mileage requirement. So in the upcoming around 2030, after 2030 or 2035, we will be going more on this type of fuel cell technology with high haulage type of vehicles. And more even in the passenger vehicles and buses also currently the fuel cell technology is used, and we are collecting more data to study how how the system is behaving in the Indian environment. So all those type of research and development activities are going on currently in our system. And now what you're seeing is what is battery and what is the fuel cell technology here. As long as in the case of battery, it is only a storage unit. So in storage, as long as you charge the power, it will be storing the charges, and it will be providing the charges for the motor. Whereas in case of a battery, I mean, in case of a fuel cell, we have to fill in the hydrogen tank, and as long as you keep the gases, it will be helpful for the vehicle for the moving forward. So battery is the storage, and the fuel cell is not a storage; it is just a chemical conversion mainly. The hydrogen gas is getting converted, chemical gas, it is getting converted into electrical energy. So that's a difference between the battery and the fuel cell system. And if you take right hand side, you can see cruising range versus vehicle sizes. So especially for two-wheeler and passenger cars, the battery domain will play a major role. As we keep changing the kilometers, FC will be covering all the other vehicle component. I mean, other vehicle categories. So that's how the now the split between the battery and fuel cell vehicle is moving forward. Now we are seeing what is the fuel cell technology. The fuel cell technology is nothing but an electrochemical devices. As I said in the previous slide, it converts chemical energy into electric energy. This component is used to do such activity. And you can see a fuel cell powertrain, similar like IC engine, internal combustion engine. Here also in the fuel cell technology, we'll be having a air filter, then air compressor, turbo will be there, air compressor will be there, then fuel stack, whatever the output. I mean, after burning, I mean, after producing the current, the end output, what we get as water. So to collect the water, there is a water separator also available. So some of the key components used for building this fuel cell powertrain is shown on your left hand side. And in case of fuel cell technology, there are different types of technology available now. Especially for the automobile, we are mainly focused on proton exchange membrane technology. The proton exchange membrane is just like a carbon cloth. You can see in the on the right hand side image, a golden brown color plate is available in the middle. Between the two blue plate, there is one golden plate that is called proton exchange membrane, which is nothing but a carbon cloth. So on your left hand side, hydrogen, you can see in that particular image, that is called anode. And on the right hand side, where water is going through some plate, it is called a cathode. So from the anode side, hydrogen gas will be produced, and the gases will go through the proton exchange membrane, whereas here also the electron will get split into electrons, and protons will get split from the hydrogen gas H2. So 2H2 is there, where one is electron, one will split as a proton, and the electron will conduct the for producing the current. The electrons will be used, and protons will again go through the other side of the membrane, where it will be collected again as a water. I'll just show you a small video how a system will work like. So as you see, the structure is very simple only. One side it will be having a anode, and other side it will be a cathode, and the middle will be a proton exchange membrane. A small prototype, especially for the lab scale, has been developed on the right hand side. So you can see how a system, how a small 1 to 5 kilowatt fuel cell system, real system will look like. And the middle water you're seeing is this proton exchange membrane. And the other outside you can see a thick plate that is called a bipolar plate, especially that is for the current collector. You can see on the top side there is a power is getting collected. So this is how a system will look like. If you are doing some if you're doing some sort of any research and development for lab scale in the colleges, you have to develop this type of proto systems for the study. Again, some basics of what you have to keep learning is on the what is voltage, what is current, and Ohm's law. So voltage is nothing but a pressure which that pushes the electricity. So that is the main criteria for the selection of or development of this type of fuel cell system. And again, the Ohm's law will play a major role throughout the cycle. So electric current is always proportional to the voltage and inversely proportional to resistance. So what type of resistance and what type of voltage and current that you need to be designed, that you have to take it according to your vehicle requirements. Now you can see the split up of each cell. Normally, what I'm discussing, what I showed in the previous slide is a single cell fuel cell system. If you go with heavy duty vehicles, especially high tons of vehicles like greater than 28 or 55 or 50 or 55 ton vehicle, in that case, you will be requiring around 120 to 150 or 220 kilowatt of fuel cell system. So you have to pile up with around 400 to 450 fuel cells together to get that much of power here. So just imagine how massive the fuel cell structure will look like. But whatever the sizes that we are developing, that should be packed within the existing fuel cell way. Existing powertrain compartment only. So we cannot develop a very bigger size of vehicle. Whatever is currently the vehicle size and what is the powertrain currently being developed, what is the size of that same size, we have to develop these type of fuel cell system. But the challenge in the fuel cell system development is what type of material selection to be provided for each and every cell, what type of catalyst coating we have to provide it. Similar like after treatment system, here also we are giving a platinum coatings. So what are the composite fuel cell plates to be manufactured? So all these things plays a major role both on the performance as well as on the cost point. So on the top picture, what you're seeing, left hand side, outside the first plate is a end plate. It is called. Second will be an electrode. Electrode is for the current collector. Then again, number of cells you can see cell one, cell two. So like that, different types of. If it is a heavy duty, more than 400, 450 cells have to be packed like that in the system. Then the middle one is called a membrane, proton exchange membrane. Membrane electrode assembly, MEA, they used to say. So which is nothing but a carbon cloth or whatever the electrons without the electrons have to be filtered out in that carbon cloth to collect the current, and only the protons will be going on the other side, and it will be again combined with the oxygen which is coming from the environment to make as a water. So only H2O is coming as a byproduct of the which is coming as a output in the fuel cell system. Again, there are more challenges in developing this type of membrane, because on the bottom you can see a cell voltage versus current density. There are three types of losses is provided. One is activation loss, next is called ohmic loss, third is called concentration losses. If you take the cell voltage nominal will be around 1.2, but we will not be getting around 1.2. We will be getting as 0.8, 0.6 something. It will be coming up in each and every vehicle, whatever you're designing. Why that voltage loss is happening is because of the three things. So one is activation. First thing is because of the catalyst, whatever we are providing, the catalyst have to heat up initially, then only it will start reacting. So for heating up, some energy is lost. That becomes an activation loss. Second is ohmic losses. Now, through this proton exchange membrane, electrons are getting transferred, electrons and protons. So when electrons are, the charged particles are moving, some resistance will be created. Because of this resistance, the flow of the electrons are restricted. Again, your the power requirement required from the fuel cell vehicle it will get reduced. So the ohmic losses will come into the picture. Third is concentration losses. As I said earlier, after H2, I mean, through anode, the hydrogen gas will pass through. Then again, it will split into electron and proton. After the electrons will be providing the current, as well as the protons will move to the other side. Again, on the other side of the cathode, where a proton and an electron combine together along with the oxygen to form water. The water have to go outside the fuel cell. There will be some restriction provided for the water transport now. So those types falls under concentration losses. So three types of losses plays a very critical role in design and development of these type of fuel cell system. So the challenge is, what is the thickness of the proton exchange membrane that you need to take it up? What is the size of the bipolar plate for the cooling, for the water transport to be provided? What type of design that you need to incorporate in the bipolar plate? There are multiple challenges are incorporated associated with this type of fuel cell system design. So for research and development teams, for academic people, there are more in for technical problems or technical challenges are available. You can study and you can get some activities developed in this particular system also. Again, in the few, what I'm showing is a bipolar plate design. So in case of a bipolar plate design, through FEA and CFD, you can find out what is the amount of oxygen flowing through this plate and how much cell voltage. On the top side, you can see the cell voltage versus current intensity. Between your numerical and theoretical, I mean experimental, what is the loss percentage? You can see the curve. Initially, there is an activation loss. So from 1.2, the curve is coming down, then followed by ohmic losses, again followed by transport losses. So how to minimize these type of losses, how to increase voltage with the minimum number of fuel cell system. Because if you use a minimum number of fuel cell system, again the cost will be reduced. Again, the packaging size of the fuel cell system and the vehicle also get reduced. So that will be benefit for the customers. So these are some of the challenges you can think about. Now, the next type is what are the types of fuel cell system available in the overall market? One is solid oxide fuel cell system. Currently, more research is going with the solid oxide fuel cell system, but the output temperature which is produced from the system will be around 600 to 1000 degrees Celsius. So managing these type of high temperature on the vehicle is more challenging. So still more research and development activities are going on SOFC. What currently we are working is the last one. You can see the bottom one, proton exchange PEM fuel cell, where the temperature is around 90 to 100 degrees Celsius, which is manageable with a good radiator system on the vehicle. So currently we are working on PEM, and then in the middle we can see a molten carbonate fuel cell system, then alkaline fuel cell system, phosphoric acid fuel cell system, dimethanol fuel cell system. So different fuel cell systems, and depending upon the different application, more systems are available where you can focus your research and development on different types of fuel cell systems accordingly. And again, the fuel cell system efficiency also plays a major role. The solid oxide fuel cell system efficiency in this slide, you can see around 50 to 60%. And the proton exchange membrane, you can see around currently 40 to 50%. So how to improve the fuel cell efficiency greater than 55 or 60? That is also very good research that you can take it up. So depending upon the different application, what are I'm showing here, space, military, or vehicle, or any generator systems, you can choose your fuel cell technology, and you can develop the systems accordingly. Here you can see what is the electrolyte structures, what are being used in the proton exchange. One is polymer electrolyte is used in the PEM membrane, where alkaline is potassium, then dimethyl, that is also dimethanol is also a polymer, then PFC also polymer, phosphoric acid electrolyte. So SOFC again, that is only a solid electrolyte used in the fuel cell system. Again, these systems will have different types of catalyst. The noble metals like platinum will be used. You can the blue color you can see, and the light blue can be used with the noble metals, non-noble metals. So you can develop your research with if any chemistry person or material science also, team wants to do some research on the catalyst also, you can use these type of metals for developing the system. So what I'm showing here is 40 roughly around for 120 kilowatt fuel cell system. Some research are showing around 400 cells they are using up. So just imagine how massive the system look like, and how 400 cells are packed in the fuel cell. I'm just showing internal structure of the fuel cell system. So one first thing is on the separator where water gets separated. Second, how the flow plate, how the water flows through this flow plate. Again, the proton exchange membrane is separated by a catalyst, a cathode catalyst for oxygen, and a for hydrogen. It is anode catalyst. Then the cooling cell. So for developing one single cell system with around 0.7 volt, we have to pack up with different systems, fuel cell plates, and cooling systems have to be defined accordingly. I'll just show you some videos here. Let us see how a bipolar plate is being developed. In addition, if you want to develop some sort of educational system, very small pilot scale, whether it is possible for doing any BE project, yes, that is also possible. We'll see how Horizon is one of the system, how it is being developed. A very small kit. A very, very, very simple system we can implement in the lab scale also. And if any final year projects, if you want to do on the fuel cell system also, you can develop your own kit like that. Okay. Now let us see inside the vehicle how the system will look like. Again, inside the system, you can see the fuel cell deck. That's how a big massive fuel cell structure will look like. Other system is on the air filter, because the cathode side whatever oxygen coming inside this fuel cell system have to be filtered. It's similar to IC engine where the air filter system is used. Here also air filter system for fuel cell will be used in the similar way. Then the amount of air which is coming inside the fuel cell, if you want to increase the pressure, increase the boost up the power, then the air compressor, similar like a turbocharger, here the electrical compressor will be used. Other side on the cooling system, how the radiator system is used to cool IC engine temperature. Here also for the fuel cell system also we have to use the radiator. So those type of designs have to be taken up carefully to reduce the heat. Now, if you see into the bigger structure of the vehicle, how the fuel cell is being packed, you can see the front side of the engine, uh, front mounting. The fuel cell system on the top side, on the left hand side, you can see the blue color tubes are going, and that is a big, massive fuel cell system packed on the front side. And again, on the right side, you can see how the hydrogen tank is placed backside the cabin. So, in the future vehicles, you are going to see these type of structures, and that's how the system have to be managed. And like a diesel engine petrol stations, hydrogen stations also will be coming up in the future. So we'll be filling the gases in the petrol bunks for the hydrogen also. So if you take uh, bigger buses, now the hydrogen tanks will be placed on the top side, and the fuel cell will be placed on the rear side, and other connections will be similar, like cooling system, air filter system, battery packs will be placed like I'm showing on the left hand side image. So this is how a structure on the commercial vehicle will be looking like. One fuel cell system will be connected on the rear side of the tires, where the battery will be connected. So the battery electric vehicle and fuel cell together, hybrid vehicles will be looking like this, high power vehicles. If you take internal structures, the fuel cell will be connected with the electric motor. Then how to control the fuel vehicle controls, there will be a fuel cell control units will be there. High voltage you can see some orange color cables were going on. That is mentioned as high voltage. High voltage means normally that the voltage levels will be greater than 450 or 660 voltages. So that where in the future, wherever you are seeing these type of orange color cables going on, you should not touch with the bare hand. That is one thing what key that you have to take it up. Similar like our regular battery wires, like the blue and black, we'll be touching with our normal hand. These type of orange wires are very much critical. You should not touch with your bare hand. That is what the color combination is also given specifically for this high voltage cables. And here you can see the different high voltage cables, how it is connected. Um, for example, if any roadside vehicle service, if you are going, what will happen if the blue color or black wire, whatever for the battery, they'll be using any type of battery wire thickness, and they will be connecting. If a known person is doing the activity on the service, he'll be knowing what is the thickness of the wire that needs to be replaced. If an unknown person is doing, then this type of knowledge will not be there. Especially if in future, if you are going to use these type of high voltage battery electric vehicle or fuel cell electric vehicle, you can see depending upon the different cross section of the wire, the current flowing through the wire also will vary. That is where you can see the orange color class 5, very high current and high voltage carrying wire it is. So that's how the current ranges will be given there. So we have to handle that carefully. And now here you are seeing the structure, how it looks like on the fuel cell system. The middle part is the fuel cell system, where other side you can see a radiator system is being used with a high voltage cable. On the right hand side, you can see two cylinders, that is nothing but a hydrogen tank for storing the hydrogen gas here. In case of a vehicle, whenever vehicle engineers are designing the vehicle, where to keep the hydrogen tank, whether to keep the vehicle at the bottom side of the vehicle or rear side of the vehicle or on the top side of the vehicle. So different topologies are available. If you take for a bus application, normally because of the packaging concerns, we will be keeping on the top side. On the truck application, it will be placed on behind the cabin compartment. And mix also will be taking on the truck application, where on the chassis side also we'll be keeping some tanks. So that's how the structure for using the hydrogen tank is also being designed carefully. Now, if you see, there are different types of hydrogen tanks are available for storing the hydrogen. Uh, Earlier, metal tanks are used, metal container type 1, they used to say, then type 2. And now in type 3 tanks, they are using a fiber resins inside, composite fiber resins, because the hydrogen gas, what you are storing will be around 350 bar. In future, you are going to use, I mean, you are going to store around a 700 bar pressurized tank. So just imagine if you're storing that much of pressure, how double walled container you have to maintain it. So that's how the metallic the currently type 4 container with the polymeric liner as well as with the fiber resin composites wrapped around we are using in order to have a better storage and good protection. Let me show how in Ashok Leyland the first fuel cell vehicle how we made and how the vehicle looks like. You can just see a So one is recharging time, especially in case of a battery electric vehicle. If you see, currently now with the current technology, it takes around 40 minutes or 60 minutes, 1 hour. It is charging time is going on. Whereas in case of a long haulage in future, if you are want to make it a little bit more faster, so just similar like how we are filling diesel engine within 10 to 15 minutes, the gas will be filled here and the vehicle can be moved on. So different in different streams, different types of research and development is going on. One is how to reduce charging time, how to make high energy storage systems on the battery, how to make high efficient fuel cell systems. Other side, what type of cooling systems to be provided for the this type of hydrogen fuel cell electric vehicle. Because as I said in the earlier slide, I used to show around six solid oxide fuel cell system where the operating temperature is between 600 to 1000 degrees Celsius. For cooling such type of temperature, we cannot use a very simple radiator system. We have to have a very massive structure. Again, packaging those type of structures on the vehicle that is going to be a more I mean more challenging. So in that case, what type of compact radiator system with the high efficiency to be used, what type of materials to be selected there, a lot of things will play a major role. Again, the air filter system also similar like our IC engine. It is not just like just filtering the um, very small particle, small stones or mud, something like that on the filter. Now we have to, since we are using the catalyst in the fuel cell system, the poisoning of the catalyst have to be reduced here because in the air also the poisoning gases will be mixed and sulfur will be there. Whether the air filter will reduce those type of sulfur in the atmospheric air, how it is possible? In the carbon monoxide, again the poisonous gas. If again carbon monoxide is mixing and going into the fuel cell catalyst, again that will also spoil the catalyst performance. So how to reduce these type of catalyst performance? How to increase the efficiency of the catalyst, improve the life. So now the working with the fuel cell electric vehicle is going to be a major challenge, and material science engineering team, chemical catalyst team, electrical team, hard I mean mechanical or automobile team for the hardware development. and how to control the energy efficiency between the battery, high voltage battery. Because in my second or third slide, I was showing the efficiency curve. When the fuel cell, if on the higher side of the power, the fuel cell curve will come down. So in order to improve those type of efficiency, wherever the curve is coming down, by with the help of battery, how to use the energy balance between these two systems. So development of good vehicle control unit, electronics team, the automobile team. So it is going to be a cross-functional handshake between each and every teams who is going to work together for developing these type of vehicles. So studying only one subject is not going to help you in future. So we have to have a hands-on experience or a hands-on subject knowledge on electrical, electronics, automobile material science, chemicals. So everything put together, we have to make these type of things. Even manufacturing again, the type of storage tanks what we saw, carbon resin, polymeric, and as well as the carbon fiber mixed together. So the manufacturing engineer, what type of materials and how it is going to be manufactured, how it is going to be wrapped on the tank to increase the tensile strength of the system. Lot of challenges is going to be there in each and every component which is going to come in the future, with especially on the electric vehicle applications. So good knowledge enhancement will be there who are taking part in the engineering studies, and just keep updating your knowledge by attending all these type of sessions and other such programs also, so that different industry people will share their experience on how they have been developed, and what type of areas that you need to focus for the research and development, as well as for to upgrading your skills. So you can collect all this information, and you can plan the research and development accordingly for the next 5 to 10 years, where to focus and what to be incorporated in your studies. Again, on the gas hydrogen storage systems, currently now we are working with a compressed hydrogen storage, where we are working with a 350 bar to 700 bar storage. Again, in future, we are going to see a liquid storage, because going 1,500 kilometer mileage, I mean, kilometers coverage is also not very less. People want to increase that kilometer coverage. So again, a liquid hydrogen storage will come into the picture. Carbon nanotubes also will come into the picture, with a minimum space, how we are going to store more number of I mean, hydrogen gases can be stored, chemical storage, how it can be stored, physical storage, like that. Different technologies we are going to see, and we are going to enhance the technologies in the upcoming sessions. So this is one of the fuel cell electric vehicle being published and being kept in Auto Expo 2023. So this was the first successful product one. Then next product followed by, we developed a 9-meter bus also. Again, we kept in Expo for 2024 Expo. So these are the products what developed earlier. Again, tested, all these systems have been tested in different terrains conditions. Now what we are doing is, we are just giving hands-on sessions, and the people's exposure, what type of technology being used, and how technology are getting upgraded. So that upcoming people will be knowing what of technology have to be taken care, how to be used up. So like that, different systems we are just discussing with the different teams here. So do you have any questions? Well, let's discuss for some time. This is just to show you inside a fuel cell system how the plates are assembled in this one. There is no audio for this. This is just only a visual. This is a proton exchange membrane plates, how it looks like in the middle. So H2 is getting split into H plus proton and minus the electron. You can see that electron is producing that current. Again, it combines other side, goes out as a H2O. Toyota also made some fuel cell electric vehicle. We'll see how it looks like. So this DC-DC is very much important, and designing the DC-DC also our next challenging task here. If you search in the internet how many types of DC-DC converter is available, you can understand it will be showing more than 15 or something. And in using these DC-DC converter, how many numbers of IGBT or diodes have to be incorporated into the system to get the to achieve a voltage range of 660 volt. That is also a next challenging criteria. So the final year students, if you want to take some type of these type of projects, please note down the supplier names, whomever I'm just showing in the videos. Just go through the website provided in the website and understand what type of product it is, and you can select your projects accordingly. So that's what I'm just showing you all these type of videos. What will be what type of project that you need to take it up, and where you have to focus on. And these type of projects are this DC-DC will be used even the commercial vehicle, bus, as well as the passenger vehicle segments also. So if you are using the fuel cell system as well as the battery systems, hybrid systems. Yeah. So that's it. Yermali sir, maybe we can discuss with students. Any questions? Because where I mean, so now industry is totally changing from to towards EV and smart mobility. I just want to walk you through some criteria. If you are searching some jobs in automobile industry, how it is going to look like, and where you have to focus, and what type of simulation perspective, what type of studies that you need to take it up to enhance your skills in this fuel cell and EV vehicle. Let me just walk you quickly through this system. One is automobile. Mainly, if you are going to choose these type of technology, you can directly go with manufacturing, maintenance, or any new developments. And second thing is now we have to learn the software and electronic part also, because in all my slides I used to show electrical and electronics and some circuit boards. So now electronic and software learning is also becomes a mandatory in this particular course now. So just try to focus your skills accordingly. Second is when if you are going to choose some sort of automobile only, and you are going to focus means if you are having more passion, especially in maintaining this type of to design and develop automobile vehicle components, or some sort of innovation that you want to develop it. So if you have some passion, just focus only on particular one single stream. Otherwise, you have to have a hands-on experience on all the streams, so that now, because of the upcoming change in our industry, especially towards the EV, now more and more updations are required. Expectations are expected from different, engineering students whenever you are coming for jobs and other thing. So in addition to the electric, this type of EV, now you have to focus more again on ADAS, this automatic driving assistance systems also is coming into the picture. So you have to focus self-driving, how self-autonomous vehicle systems is to be developed, because now everything is electrical. Now we are moving electrical, so now ADAS and other different types of features, artificial intelligence, everything are coming together in one single vehicle. To be more specific, we have to say it as a software defined vehicle. That is a terminology what they used to call. So different software updation, cyber security, everything now it is going to fall in the vehicle system. So you have to focus on that. Okay. And if you are going to focus your career on the fuel cell system, now these slides are very much important. On the right hand side, you can see each and developing each and every time a new vehicle and testing the vehicle is very difficult. So what we will be using is GT software is a technology name, software name, or AVL Cruise. In that, these two software, you can see electric vehicle, motor, battery, fuel cell, everything as a component wise it is available. Only thing is we have to have an integration of all the system in the software. You can see the picture how it is integrated. Not only the passenger car, on the bottom also you can see the two-wheeler, how a two-wheeler system, motor, battery, systems, the driver, how he is going to drive the vehicle, how a driver actuation is going on the vehicle. All the systems are now software built. So each and every time there is no need for developing a new component, test it on the lab. You can develop everything in the software itself, and you can define the system. Second, I was talking more on the bipolar plate and solid oxide fuel cell. So in case of a solid oxide fuel cell, what type of a radiator you have to select, and whether the radiator is adequate for cooling or not. So on the left hand side, you can see a image, the radiator image. The top side, you can see how the cooling efficiency is taking over the radiator. The red and green, you can see the color ranges of the temperature, how hot it is, where it is not hot, how where it is cool, other thing. In the middle, you can see a battery electric vehicle. Now we also discussed on the battery vehicle. So the battery component also get heated frequently. To cool the battery system also, we will be using a radiator. So in this software defined vehicle, we can see how the battery efficiency, the battery cooling takes place over the system, and how the temperature ranges looks like. So this is on the battery. So the one software what I discussed is a GT suite, and other software is AVL Cruise. Please note down this, and you please also browse and check what how the simulation is carried out using these software. Next is bipolar plate. You can see the bipolar plate is a component which is used in the fuel cell system, which is the end plate, used to call end plate. Again, the temperature flows over these type of end plate also. There also you have to see whether the cooling system is adequate over the plate. So the third picture on the bottom side is a bipolar plate, and the temperature ranges how it happen, how it spreads over the plate. That is how the temperature profiles I'm just showing there. So all these type of simulation we can do it easily using the GT suite software, as well as the AVL cruise software. Second, I'm just showing you a market share. Sir, now the industry is totally changing with the fuel cell, electric vehicle, IC engine, and different alternative fuel are coming. So where to focus the career, how to, uh, what type of project we have to focus. Just you keep watching the production or manufacturing of each and vehicle components. The vehicle ranges, whether the two-wheelers or passenger car or four-wheelers, the truck, commercial trucks, whether it is bus or truck. You can keep watching the production units of these vehicle, which will show you where more demand is there. What is the market share? So more demand where you are able to see passenger and two-wheeler. So the more focus to be showed on the passenger, where easy of getting the jobs. Then next comes three-wheeler, the passenger car. Then one comes truck and bus application. So these type of database you have to keep watching, and you can collect all this information from CM, Society of Automotive Manufacturing Association. There is one separate website where you can see all this information. The database collection is there. So keep watching all these things. Well, now in future we can see whether the EV market is growing or IC engine market is going, alternative fuel is maybe we can get all this data there also. Then, sir, in market share, the vehicle market itself, off-road market is there, on-road market is there, where to focus and what type of vehicles each and every manufacturer are doing. So these are off-road markets where tractor brands I'm showing. So Mahindra, Swaraj, Eicher, Force Motors are different companies where focus mainly on the tractor application. So go and watch each and every website of their this vehicle manufacturer. You can understand what type of job opportunities are available in each and every vehicle segments. Whether their main requirement they are asking on the electric vehicle or battery vehicle or fuel cell electric vehicle or IC engine. So accordingly, you have to focus your projects and you have to get more developments on and enhance your skills accordingly. On the right hand side, if you take the passenger segments, again, BMW, Chevrolet, Ford, or Bentley, so different markets are developed. There also, again, if you are interested to go in the passenger car application, these are some of the brands and some of the websites where you have to keep browsing and you have to understand what type of job opportunities they are asking frequently and what type of enhancing skills that you need to make it up to get these type of jobs there. So this will be more helpful for the PG and BE students where you have to focus all your projects and upcoming skills accordingly. Sir, if you want to focus more on, again, on the two wheelers and Hero Honda, TVS, Suzuki, again, electric vehicle manufacturer, Ather, Ola, Ola Electric, Ampere, these are the electric vehicle manufacturer. Again, TVS Motors also doing some electric vehicles. So you have to watch all these systems, all the vehicle manufacturers and understand what type of jobs they are giving. If you want to focus on the truck and bus application, again, the Tata, Mahindra, Eicher, Volvo, Ashok Leyland is also focusing on this type of heavy duty trucks and bus applications also. So just focus on it. On the right hand side, you can see Sunlong, Asia Star, BYD, Toyota. All these on the fuel cell electric vehicle and battery electric vehicle. More on the battery heavy duty applications. These are some of the Chinese markets also available. So understand in their website what type of product they are doing, what is the specification of the product they are giving for the customer. Because whenever you are applying for the job opportunities, you have to write a covering letter. During the covering letter, you have to specify, you have to tell about their company, why you like this company, how your interest aligns with the company goals, why you are applying for that company. All these things you have to discuss in that covering letter. So only I'm just showing you all types of OEMs and their logos. Just keep searching their informations and keep updating yourself regularly. Okay, if I'm not going to focus on the vehicle manufacturer, what is my next level of opportunity? Then you have to focus on the tier one suppliers. The tier one suppliers, you can see the Bosch, again, electric component manufacturers there. The vehicle control unit systems, wiring harness, or the DC-DC motors, hydrogen sensors. So all this manufacturing, manufacturers under Bosch or Continental. Again, there is a catalyst company uh, where the platinum catalyst is getting evolved, right? So you have to get some chemical catalyst, means you have to contact BASF, Umicore, UMIC or Umicore. They are the catalyst manufacturing suppliers. If you want to focus on the cooling system, sir, I want to focus on the radiator system. BorgWarner is a company where you have to focus there. Sir, I want to focus on the air filter system. Then you have to check a Man and a Hummel, which is in Bangalore. I'm not showing more and other, still there are more companies that are available. On high end, I'm just giving you some ideas of the companies where the fuel cell electric vehicle components are getting manufactured. Developments are focused, as well as the manufacturer, the vehicle manufacturer who is doing the fuel cell electric vehicle, so that you can. This is a revolutionizing technology. You have to find out the products, what is getting developed or what is innovated in these type of companies, and you have to prepare accordingly. For that only, I'm just showing all these slides here now. Okay. Now I'm not interested to join the OEM or tier one company. I want to focus mainly on the research and development of the fuel cell vehicle or electric vehicle, or to certify the electric vehicle. Means there are three companies. One is Automotive Research Association India, ARA, which is in Pune. Then GRC, Global Automotive Research Center. It is in Chennai, Varagadam, and ICAT is in Delhi. So all these three R&D centers is used to certify the vehicle, whatever is getting developed by the different OEM, whether it is meeting the safety criteria. As I said earlier, the orange cable, high voltage cable, means it has to be protected without giving any electric shocks for the customer. So, or any service people who is doing any change of the component during the service interval. So all the safety critical systems have to be tested, and it has to be proven safety for the vehicle and customer but under these companies. So these are R&D centers. Next is, sir, what type of skill development that I have to enhance myself because of the change in the electric vehicle revolution. One is you have to focus mainly on the CATIA if you want to do the design and development, or if you want to understand uh, work the battery temperature. Understand the, I'm just below, I'm showing you a battery where it is fire is getting coming, right? Because of the temperature control if it's not there. So in that case, how to understand this means you have to learn ANSYS or ANSYS CFX, or this Cosmosol or Gamma technology, Thermo. So these are the different types of software available where you can simulate the real world problem in your computer itself. So this is called a simulation team. So if you are more interested, you have to do a project by taking these type of simulation jobs and the simulation activities. Sir, apart from this 1 day session, I want to still understand more, get more information of different technologies available with the different OEM experts. Means you have to get familiarized with the ARI skill development program. They will be sending these type of brochures. If you join as a member, they will be informing you about the programs, where it is taking up, who is the expert giving that program. Then in SCAE India also they are doing. Again, yes, EME, which is a e-mobility in Coimbatore, they are also doing. Cosmos are also used to give some lectures. So you have to register yourself, and you have to keep tracking all these informations. Sir, what type of, I mean, if I want to get more number of salary in the starting stage, so MNC companies where AMG or Bharat Benz or BMW, Renault, all these are used to give a lucrative job offers initially. So if people are focusing, I want to only go the lucrative jobs, then you can search these type of MNC companies. And what type of job opportunity they are giving, because when you're starting your career, it will be given as a executive, sorry, automotive technician is a lower level. Next, service advisor, if you are going any service center, they will be giving as a service advisor or workshop manager. Then automotive developer, whatever the codings for the software defined vehicle, if you are going to take a job as a software defined vehicle, then automotive developer job they will be giving. Or if you are taking as a CATIA skilled developer, then it is a mechanical design engineer. If you are going to sales, means marketing expert, then a quality expert, a quality engineer, then automobile designer, production means a production senior production engineer. So like that, managerial roles and different roles will be available. Then, so if you take salary level, if you start during the starting salary around 64,000, you can see, up to 2 lakhs per month. Also, they are providing from these type of tier one companies after completing your BTech. But you have to develop the skills whatever I shown earlier. Then only you can demand for the jobs. So apart from the electrification, you have to first thing is the topmost now industry trend is electrification. That is what you saw today. Next is in the same vehicle, again, the shared mobility is one of the technology. Artificial intelligence, especially the data whichever is coming in the fuel cell electric vehicle, a big number of data will be coming up. So every day we have to monitor the data, understand what is the health of the vehicle, and you have to inform the customer your battery is coming down, your battery health is coming down, and your battery temperature is increasing, your fuel cell temperature is increasing. Like that, you have to manage the big data, and you have to understand, you have to do some data analytics, and you have to give a feedback to the customer before the failure. So big data and data analytics, another big stream which is going to play a role here. And human machine interface, just by voice calling, or you can, by sitting in this car itself, you can make the vehicle to start by just giving your command. So all this comes under the human machine interface. Then in IoT, Internet of Things, again, in the mobile you have to keep monitoring whether your battery level is good, or it is going, whether we have to change the battery with a new system because of the health issue on the battery. Like that, all information will be capturing in the IoT. So autonomous driving vehicle, which we saw in the earlier system. So autonomous driving vehicle, connected vehicles through AI powered systems. This is how the system is going to have a change over in after 2035. Now itself, ADAS vehicle were coming up level 1, level 2. So there are still more levels are available. In the upcoming sessions, you will be seeing I mean, not session, upcoming years, you will be seeing these type of technology incorporated in the vehicles, along with the electrification. So these are the part of electrification, connectivity, how your different system, by sitting in your car, the GPS system, in which route you are going to travel, or for traveling that particular route, what is the hydrogen store level in your tank, whether still whether you have to boost up the level. So all these informations will be coming as a connectivity. Electrification we already saw. Again, shared mobility. So upcoming cars, if it is electrified vehicle, again, like a Ola or Uber, these cars also, now electric cars also will come under shared mobility through using your mobile systems. Again, using artificial intelligence and machine learning, the system will understand what type of problems are coming in the vehicle, and what steps that it have to take automatically. So all these are artificial intelligence. So now the entire vehicle is getting moving into artificial intelligence incorporation also. This is a big data analytics. Mainly it is for the decision making using the big data. Again, additive manufacturing. The bipolar plate, whatever we saw earlier, if you want to do something in the lab scale, you can use a additive manufacturing technology. You can develop the product immediately, or within lesser time, and you can see how a product structure looks like. So based on this, you can go for a bigger, higher productions. So overall, not only the electrification, in addition to the electrification, all these methodologies, I mean, all these upcoming technologies also, you have to keep updating, and you have to enhance your skills for getting, or to get developed, or to use for the new technology. You have to get adopted with all these new technologies now. Yeah. Any questions here?
Participant, if you have any question, you can ask. I given permission to mic to everyone. If you have any question, you can ask him. Sir Karthikeyan sir, I think that's all, sir.
Okay.
Thank
Okay.
you for accepting my invitations and given the valuable lectures, sir. Thank you
Yeah.
so much,
Thank you
sir.
so much. Thank you all. Thank you so much. Have a good day. Bye.
I request Dr. Banu sir to give a brief introduction about Mr. Shiv Subramanian sir.
This is Dr. N. Bhanuteja, Assistant Professor from Mechanical Department, Aditya University. I take this privilege note to introduce Dr. Shivakumar Subramanya Rajkumar. Is actually from a mechanical engineering background with over 10 years of experience in academia, research, and industry. His expertise covers automotive pollution control, combustion kinetics, and computational tools such as MATLAB and Python. He is currently working as a powertrain and calibration engineer at AVL Ibrica in Spain, contributing to dyno testing, test result analysis using AVL Concreto and Python-based fleet test programs. He also served as a research intern at the University of Valladolid, focusing on combustion instabilities in alternate fuels. Previously worked as an assistant professor at Dhanalakshmi College of Engineering, guiding students in Baha SEA and even research activities. So, I would like to hand over the mic to Dr. Siva Subramanian Rajkumar to continue the session. Thank you, sir. You may take the presentation.
Thank you, sir. Thank you for the opportunity for the whole team of Aditya University. And thank you for the HOD, Dean, and all the faculties who gave me the opportunity to present this topic. So, uh, after a Christmas evening, the warm evening, we are starting with a topic of hydrogen and fuel cells powering for future of clean energy. So it was completely focusing on the clean energy system of upcoming future of our global environmental systems, and we are focusing on that. And with addition to that, AI power technology and the AI power systems so for optimization of this clean energy, how we are going to adapt the new technology into the existing ones. Uh, we are focusing on why focusing on a clean energy systems for the current environmental, and what are the basics of hydrogen production technology, fuel cells, and application, and the outlook, and how to adapt our the AI technology for the upcoming future systems. So these are the things we are going to brief on this region. So this is the air quality index of today morning about India. The red dots all the points which we can able to see that these are the poor air quality index which was above 400 and above, which means that this data was taken today morning at 9 o'clock. So we can able to see that entire India was majorly on the red zone, and the violet zone also in the endangered one, and the light yellowish color was little bit lower, and but still we are in a danger zone. But after that, in the beyond the uh, Tibetan border, we can see that green colors, which means the region we can able to live. So first of all, we have to think about why the region has been red and why we are focusing on a clean energy. Both are interlinked terms. Okay, and the highly today the climatic change was very severity in Haryana, which was Bhiwani, which was 12.3 percentage has been improvement, which was change over compared to last 15 years. These are the current data. One was the weather data, other one was air quality data. We know very well from the November to January, the Delhi NCR region will be entirely will be the air quality was very poor. The air if air quality was very poor means it was to be we can say that people should not live on that particular place. Even we have that one type of 144 adapted in Delhi for certain things which should not be operated on the Delhi region, which was a generator. Recently, they have done that one. A generator was not able, should not operate on Delhi region because of air quality. The greater thing, these things are coming under the category of a clean energy. If we are using a clean energy system, and the output should be the air quality should not affect, right? So these are the things. The shocking parameter was the shocking thing behind the screen. Only India have major compared to China. India was majorly on red dots. If you see that China and Europe, we can see that China part only on few mining cities and few cities alone having a air quality index at the red dots, and the other regions are in a green. But entirely on the Europe, entire Europe, Spain, Italy, and every region has maximum on a green color. So these are the region for people can live in a better life. But here we are not able to live with the air quality index with this category if we are living, and we will not able to survive more than 40 to 50 years. These are the reason for the clean energy we are focusing on. This is the major reasons. Okay. Uh, when you focus on China, China is majorly doing the mining process, and all the battery equipment and all the mining materials are coming from China, South Korea region, and other regions. So they are giving the mining materials and the semiconductor chips and all. We are making from China is the leading partner, and Tamil Nadu also. We are trying to make semiconductor hub in India. We are doing the Tamil Nadu was doing a better semiconductor hub for it currently. But if we are doing this kind of activity, our air pollution will be more, and in particular region we are not able to live. So clean energy is not mean about the combustion parameter and emission parameter. It's not about completely on the only emission parameters alone. We should not think about. This is the data once upon in 2022. I have worked on the datas, which was the I was wondered about that before doing this data. Whether I was thinking about that the four-wheeler emissions are greatly influencing on the air pollution. We have a lot of pollution, was industrial pollution and other pollution we are thinking about. But in this case, I have worked on the emission data versus total number of vehicle sales. Total number of vehicle sales and what grade of vehicle we are selling out from 2014 to 2022. So we are comparing with 2012 data, 2018 data, whatever the data which was available. We are comparing the results, emission data, sales data, both. Okay. Yeah. End of these results, we have identified that two-wheeler was causing a more pollution compared to four-wheelers because of sales. In every home, we will be having nowadays. We will be having around 2 to 3 two-wheelers and one car probably. So two-wheeler was the major cause, and for the currently India is the world topmost population we are having. So every comparatively population for every home around 3 vehicle, then the we are giving a lot amount of emissions to the global warming and other things. So these are the data. We have collected this data from the sales, which was a government only for Chennai. We have done this one. This is for Chennai city, Chennai district or Chennai city alone. We can able to see that only the Pundamalli, which was the zone for industrial area, more populated industrial area, and more amount of vehicle movement will be in this region, so that we can able to see that vehicle sales and the emission also cumulative emission was occurring on this particular region. When compared to four-wheeler, we can see that Pundamali was not having operating of higher four-wheeler drives, but in the inside of the city, we can able to see that city was having a larger amount of four-wheeler and the emissions was occurring on the particular regions alone. So these are the regions and causing the pollution to the in India particular district. So when we go for the whole India, go to the previous case, when we can see that these are the why the air quality index was affecting. One of the cause was transportation and IC engine emissions. We are thinking that two-wheeler, four-wheelers and trucks are doing that, but not that one. Two-wheeler is the major cause. And after the major causes, we have concluded that from this data, we can able to conclude that public transportation will reduce the vehicular emission only for the vehicular emission. Um, we are not updated to the current scenario, which was the particulate matter from the vehicle. Euro 6, we are using a Euro 6. Currently, we are adopting Euro 6 vehicles are on sales. But when you go for a Euro 6 higher grade in the Europe and other countries, they are going for Europe 6 itself. They take the particulate matter from the vehicle, which was a wear and tear of the tire and road. So at the time, the particulate of a tire molecule, which will cause a larger amount of particulate matter, and that was causing the major air quality index that was affecting. So when huge quantity of vehicle was moving on the particular region, it will affect the complete system air quality. So two-wheeler is the two-wheeler and four-wheeler. So comparatively, when we are shifting to larger amount of when population was shifting to the public transportation like buses, train, then this kind of pollution will be reduced. These are the outcomes. And because in the European countries, they are taking the particulate matter of a particular vehicle tire, that also calculated, that also to be monitored in the future. In our cases also, when we are shifting to from Euro 6 to Euro 6, yeah, there was a number, yeah, D and Euro 7 and all. We have to include the particulate matter of from the tire. And the CO2 emission, the global warming causes occur due to the CO2 emission from the mining industry and other cases. When you check that, the climatic change occurs because of CO2 emissions is one of the major reason. We can see that China was contributing 30.9%. When you the brownish color, Miranda, that color was in Asian countries, China was contributing larger amount and India was 7.3. Totally, it was a 48.3 percentage of metric ton of CO2 emissions was occurring. If it goes like this, then entire global warming, and currently we have an issue with the Himalayan and Aravalli mountain was have a in danger. The glacier was melting and the entire system was under danger. And if it's every December, we can see that the flood was occurring, and the landslide was happening. These are the reasons. One of the beginning the reasons was CO2 emissions and other global warming conditions. These are occurring parameters. And when you compare to North America, which was a Canada, US, and Mexico, when you see that only 16.1 percentage, which was a half of the China CO2 emissions was occurring on the northern part of America. And when we consider to Europe, which was very less than totally entire India was giving little bit compared to Indian CO2 emissions. Uh, when we have to think about the other global countries, there was a they were strictly adopting the rules and regulations for emissions, and strictly adopting for the public transportation, and they have the public transportation was well versed in European countries. And whatever the even they have a four-wheeler vehicles which was having a higher standard of emission norms, which was Euro 6 and above. They are ready for Euro 7 also. Now we have completely shifting to Euro 7 emissions. And I spoke with some of my Indian colleagues who are working in Indian manufacturing company, which was a Renault. They are not able to focus. In Europe, I was working for Renault factory, and I understand that their as per European standard, they can easily shift to Euro 7 norms. The engine was upgraded, the engine was hybrid, and we know the system of dual fuel system, which was a hydrogen or CNG with the petrol. both combined combustion system. These were not marketized or a commercial segment. It was not sale so far in Indian, but they are ready to implement that particular sector with a dual fuel system for commercial segment. We are ready. We're ready for 2026, and we are ready to able to market the dual fuel system. So it was a end stage of research one. So all the things were okay. So we can able to see that these are the emission categories. Why we were to focus on the cleaner energy, air quality index, everything. Then the other thing, people were saying that okay, we are having a global warming and the system of emission. These are the IC engine emissions. So we have a myth, which was a battery vehicle. If we are shifting to battery vehicle, that entire global warming will be reduced. It was a myth. Literally, that we have a standard research from the IIT professor, the Professor Avinash Agarwal from IIT Kanpur, who was carefully studied. It was funded by Indian government and China government. They have completely studied the battery vehicle and as well as IC engines. So when we go for a battery electric vehicle, it it was emitting 15 to 50 percentage more greenhouse gases emissions. We have to, we are not initially, we are analyzing from the tailpipe emissions alone, which was not very good, right? We have to analyze the life cycle analysis of the entire process from the battery manufacturing, from the factory inlet, or the product, whatever we have mining, or from where we have mined, and where we have scrapping this once the battery was used, and it has to be disposed, right? Where we are disposing, how much amount, how much time period it will take to degrade, or whether we can reuse it. The complete life cycle of the battery vehicle has to be analyzed. When we are analyzing that, we are mining, from the mining place we are having a lot amount of gas emissions are occurring, and when we are utilizing, we don't have a greenhouse gas emissions. And when we are disposing that material to land, or somewhere else, we are just keeping the material in the outside, then it was again emitting the greenhouse emissions. So comparatively, it was having a higher amount of greenhouse emissions. It was a study done by the professor. Okay, then the coal reliance engine. Then when we are going with battery recharge, okay, we are using the power. Uh, when we are using the battery charging power, or lithium ion battery, or anything we are charging, or we are using acid, whatever it, the most of the battery charging was occurring through coal mining, and from that we are producing a power, and again we are using it. So India was the small scale. We are having a large amount of population, which we are majorly depend on coal. The 75% of the electricity was dependent on coal, and other was the few was nuclear, and other was a thermal power stations, and hydropower stations were dependent. And we know that Russian president who came now in Tamil Nadu, they are expanding that nuclear power plant with Russian technology. We are going to expand that one. So that also, even it was a current trend. We are implementing that. Even multiple nuclear plant was implemented also, which was not much more efficient to reach our global, for an Indian population, which was not able to demand, not able to meet the demand in the basis of nuclear also. And the cost of hybrid vehicle or battery vehicle, we know that minimum cost itself is 16 lakh to 15 lakh and above. It was cost. When you go for a SUV vehicle, then the cost will be much more higher. Then the cost was 15 to 60% higher compared to IC vehicles. So The solution was given by the professor, which was a hybrid electric vehicle and our fossil fuel technology. Both has to be combined. Then it was a better for our current population and current scenario. These are the report which was submitted to government. Give the statement to the government. So we have to focus on these three parameters. Battery vehicle was not good enough to go for the battery vehicle was not very good enough for cleaner energy. And when you go for a fossil fuel, that also having issues. So these are the reason. Then we have concept or the first vehicle which was we have done the auto designed a cycle and they experimented with the hydrogen, not with the petrol or diesel. The initial state of automobile vehicle was designed. That the first one was done by autos with the hydrogen only. They have done what. Then we laterally we have a fossil fuels and we shifted to fossil fuels and we have a larger amount and still we are using that one in next 20 to 30 years. We will slowly shifting to fuel cells and hydrogen equipment or hybrid vehicles. We will shift it. But the practical difficulties with the hydrogen was the properties and the nature of utilizing and other things. The property as a gas at room temperature was highly flammable. Even at 1 atmosphere, it will having a boiling point, which was a minus 252.8 degree. We have to make it the liquid hydrogen has to be maintained at very low temperature, cryogenic temperature. If it's in a gas, we have to make it around 350 to 700 bar. The tank has to be make better one with a greater thickness, and the production cost was very higher. Even with the vehicle also, we have to design properly. If any we are doing a crash test with the hydrogen, we know very well it will give a hydrogen bomb effect and everything will be blast. So which having a higher energy content than gasoline and other things out there. These are the types of hydrogen which was available in market based on the production methods of hydrogen. When you go ahead with hydrogen production with the coal gasification, there was a two category. We will call it as a black or brown hydrogen from the coal. The price in India, which was a dollar of $1 to $1.5 in India. And in the cases of gray hydrogen, it was methane reformation done by the natural gas, and the price was little bit higher because we have a reforming the things, and we are uh, the hydrogen separation was not costly, but when we are going for utilizing the pure hydrogen and the purpose of application, based on that, we have to spend more amount for making a purity of hydrogen, remove the other elements from the hydrogen gases separation, and we are after then have to utilize. Otherwise, that even the small quantity of sulfur in that element will corrode the systems. And when we go for a blue hydrogen, it was a coal or methane from the fossil fuel. We are making that it was a price little bit average compared to black or brown hydrogen. It was a little bit higher, but average in reason. Turkish hydrogen having a pyrolysis process from the methane, which was cheaper compared to which was equal to black or brown hydrogen. Okay, so that doesn't have. When we are going for a pink hydrogen, it was done by the electrolysis process from the nuclear energy. But the pink hydrogen, we are not much. We are not much more on that one, and we are not doing large quantity also. It was in a prototype. In India, it was in a prototype category. The green hydrogen was done through electrolysis or biomass with a renewable energy. The green hydrogen was only the cases for the fuel cell technology or electric vehicle fuel cell vehicles. We are using a green hydrogen, maximum focusing on that one. And the cost of green hydrogen was a little bit higher compared to other one. Why it was higher means due to we are utilizing large amount of investment was needed for such a cases. When we are focusing on the nuclear energy, we have to create a nuclear plant or nuclear energy. The cost of setup and the raw material cost, everything will be included. Then the per kg cost will be rising. And compared to renewable energy, we need a electrolysis process. For that, we need a current. We have to take something from the current, which was a renewable energy means we have take it from the solar or wind energy or ocean thermal energy, which has to be which are the renewable energy which we have to take it. Again, we need to invest huge amount of huge quantity or huge amount. Larger material cost will be there. That particular type method we are investing and we are making means it will cost much more higher. And the scheme implementer agency, they are ask, these are the future or upcoming one currently government was doing. Scheme implementation agents was calling for the proposal in consultancy with the Ministry of New and Renewable Energy for establishment of testing facilities, not with the existing one. Government was ready to, if you are a government organization, they are giving 100% resource to you and 100% cost was given to you, and utilize that cost and making a testing facility for the future and making the production of hydrogen with a green energy, green hydrogen. Government was giving the fund. If it's a private organization, they are giving a 70% of the testing facility equipments and purchasing and developing of green hydrogen with other ideas and other things. So if anyone was willing to take about this, think about this hydrogen area or green hydrogen area, please look over on that area and you will get some propose those things and we can get it. And green hydrogen. Green hydrogen hubs were already implemented in three ports with the investment of 19,744 crore in 2003. Already we have done that one. Deen Dayal, and one was in Gujarat and other one was Odisha. Other one was in Toothukudi. It was a triangular of Indian part. They have connected three triangular part of Indian and they have implemented. Government has invested this much amount for making a green hydrogen hubs, which means nothing but only the green hydrogen production unit. It doesn't mean that we are utilizing on this region for renewable energy sources, which means we are in doing a better wind energy on this region, which was all these three region was seashore seashore, so that we can utilize that one. And and we can make it some solar and ocean, all three can be connected on this region and we can make it larger quantity of renewable energy and utilized for green hydrogen production. And already in India, there are two fuel cell vehicles has been done. This is the top one bus we can able to see, right, which was a Ashok Leyland vehicle, implemented the hydrogen vehicle, hydrogen fuel cell, which is the world highest altitude of green hydrogen vehicle was running on that. That one was a NTPC was done that one, which was a Leh. We know very well about Leh Ladakh, say, right? So it was on the Leh. The second one was at a Greater Noida. Indian Oil Corporation was done the green hydrogen fuel cell bus, which was in other places. We have, but we are not completely commercialize all the sector. We are on a trail basis or one or two buses. For we are moving towards the clean energy, but not completely moved. On trial basis, we are doing these things and we are trying to do that one. And The production methods of hydrogen, we have to see on the production methods. These are the production methods, which was a steam, methane reforming, electrolysis, biomass gasification. So these are the major one, and the steam, methane reforming and electrolysis process are the easy to utilize. Steam methane was industrial process. Electrolysis was a small scale also we can able to do. We know very well electrolysis process was a reversible type of fuel cell. Once we will enter into the fuel cell topic, we can able to see the electrolysis of fuel cell or fuel cell. Both are reversible one process. The steam methane reforming process, I will show the flow diagram. We are giving natural gas and we have to desulfur the natural gas. Whatever the quantity was sulfur in that one, we uh, we have to use the desulfurization. We using the zinc oxide bed. With that, we have to remove completely sulfur has to be removed and pre reforming, and we have to again clean every parameters of the fuel which using the bed. And after then steam has to be injected and fuel has to be used. Steam has to be formed with a external source of fuel which might be coal, and the shift conversion and the pressure swing adsorption, which is nothing but separation of once it has been done from the natural gas, it was not completely purified hydrogen will not be released on the end stage. So we use a pressure swing adsorption, which will separate the whatever the gases will be there, right? Inside the chamber, it will be separate only hydrogen as a uh, it will separate the hydrogen and other gases to the exit in another direction. So these are the flow chart for steam methane reforming. This is a common method and easy to handle. And the reforming, the pre-treatment was only for sulfur removing, and the reforming was done by uh, at a high temperature of 800 to 1000 degrees centigrade. Catalyst filled tube, which was a nickel based one, and a carbon monoxide has been used. And we can see that the reaction was CH4 plus H2O. CH4, which was a natural gas, and another one was H2O, also steam. And we can see that endothermic reaction will apply, which see that endothermic reaction was the fuel was used to heat that one reforming places, so that CO, carbon monoxide will be separated and 3H2 will become, and then that particular carbon monoxide will react with the H2O and give us a CO2 and a hydrogen. Again we will have a in the reaction we will have the hydrogen completely removed, and that gases will be one of the CO, CO2 and hydrogen. So we have to separate the CO and CO2 from the system, and again we have to use the hydrogen. Okay, that system will be done by the pressure swing absorption. The next case was electrolysis process. Electrolysis process was done with the splitting of water using electricity. Okay, this is a zero emission renewable. In this case, we have a CO2 emissions. It was not completely renewable energy category, the steam methane reforming, because when we are using a hydrogen, even when in the previous case itself, we told right the battery vehicle, and the battery vehicle we have to completely analyze the life cycle analysis for the battery one. When we see that hydrogen is the cleaner energy, it was another end use of combustion alone, it was a clean energy. But in the case of separation, steam methane reforming, we have a emission of CO and CO2. It was not completely clean energy, right? So when again we were going for electrolysis, it was a clean, renewable energy with a clean energy system for separation of hydrogen. The first one was not under the category of clean energy, and the other one the H2O was feeder, the anode and the cathode will be there, and we are supplying the current voltage to the system, so that our system will separate the oxygen and hydrogen in protons and electrons will be separated from the membrane, and then we can have pure hydrogen flow. so that we can utilize for the hydrogen separation, and the pure hydrogen will be used in the combustion or fuel cell technology or anything. So this is the chamber electrolysis. The water will be come from the bottom, and we will supply the cathode and anode will be plugged in with a battery or DC current with a 12 volt, and we can do that one, so that the electrons will be flow from the both the direction, and OH radical will be flow from cathode to anode, and we will have the hydrogen gas on the one end and the other one on the oxygen. So from the atmospheric one, we can separate from the water. We can separate these things from the electrolysis process. So we can able to clearly see that anode and cathode will utilize this one. So for this also, the system which was operating here, the system operating, which was at CO and CO2 emissions. But here we need again electricity, which was a DC current or AC current to do this process electrolysis. Again, it was under the category of for life cycle analysis. Under the again, it was we are using the AC or DC current, means it will coming under the non-renewable energy sources. For this system, for this electrolysis process, we are doing the uh, at this category. In this region, we are investing huge amount and producing the electricity, and using electrolysis process, we can separate the hydrogen. So from this case only, we can able to do the green hydrogen process, not with the steam reforming process. Green hydrogen means using electrolysis, we can able to achieve 99.9% of green hydrogen in these cases. But in the biomass one, we have to give a residual biomass or biogenic fractions, and feedstock has to be given, and the gasifier we have to burn it and do the everything. Char and ash has to be disposed. Again, it was polluting the environmental system, and the gas has to be cleaning. We have to give a heat and power systems to the gas cleaning system, and the gas has to be conditioning, which has to be uh, one was that cooling system has to be placed, and every system we have to condition and separate the hydrogen, gasoline, diesel, chemicals, everything, and separate all the elements and have to utilize. And the investment of this biomass system was huge. When we are production in the quantity, large quantity, it will need we need a large quantity of investment. And the second case, it will not be coming under the category of renewable energy, not come under the category of renewable energy, because we will disposing other quantity of fuels and other things. So conversion of things, the CO2 gases also will be there. CO of reacts with the water, and H2 will create more hydrogen. And the filter membrane system has to be more pure for creating a hydrogen gas, and the operating temperature was high, 700 degrees centigrade, and we have to focus on that higher. For operating on a higher temperature, we have to focus on the that particular fluidized bed or gasifier chamber. Everything has to be focused. The furnace has to be made with better quality. When we are on the pipe, has to be the pipe flow line has to be monitored properly. All the system has been huge amount of investments and things. And this is one of the case study which was used the geothermal powered hydrogen in Iceland. You know very well, in the European countries, the temperature of Iceland temperature of the Iceland country will be very low, which will be maximum on negative temperatures in December and all. It will be on negative temperature, usually on minus 20, 30, and some of the places will be minus 5 in December. So they are not able to use the renewable energy sources, which was which was geothermal energy is the only possibility for them. Geothermal energy was possible to adapt the system for them for a renewable energies. But in the case of Iceland, mm, they have done that only on electrolysis method in Helshedi in particular place, and that other one they have used another method that active volcano areas will be right Karfla. That particular area having a hydrogen gas and natural gases will be expelling. That particular gas was captured and utilized for separation process. So it was easy to capture, right? Easy to do that investment on a particular area. But one of the risky factor was when we are investing around 20,000 crores or 30,000 crore on a active volcano area, that entire system will be get damaged, or the 20,000 crores will be washed out on this particular area if we invest on the plant invest. But in the case of geothermal, it was safe and able to operate, and we can use it for electrolysis process. This was the one of the term green sources, clean energy. Then pipeline networking. Why we have to study that pipeline networking means Europe has focused and India also done some cases. Transportation of hydrogen. It was coming under the category of transportation. We say that the property, it was a flammable material, and even at 1 atmosphere, we have to maintain at a cryogenic temperature when it's a liquid, when it's a gas, we have to leak detection has to be monitored. These things are there. So Europe, in UK and Germany, they have done the hydrogen blending with the natural gas for public and private networks and for the government assessment, and they have employed that one. And there was a greater difference in European structure. They were never using the gas like a LPG or CNG for residential cooking. They are using a electrical based stove. The entire country, even in the Spain, if you coming to this Europe country, they completely depend on the electrical based system. So when the electrical system, this particular hydrogen blending was utilized for residential heating. In India, we will using the AC systems, right? But in the European system, they will use only the electrical heating, gas heating or electrical heating for the room temperature. They have shifted from that traditional wood chimney heating in the inside the home. They have shifted to electrical heating, gas heating. So that particular gas heating for the interior residential area, they are using a hydrogen blending, which was a 20% target has been focused and utilized. For that, they have done that one. But in the Canada, they have done only with a 2%. And in Canada, one of the location for 2,100 customers with a high a 5% of hydrogen blending with the natural gases was done. But India, they have done that for whom we are supplying some of the cities having still in some of the cities in India, they are not deploying the gas cylinders or buying a gas cylinders from a particular vendor. In Chennai, one of the location uh, in Porur, one of the larger populated apartment having a pipeline gas system for cooking. So particularly on the such a kind of a system, we can implement the more purity of hydrogen has been, or like a 2 to 3% or 5% has been deployed for your home usage, so that natural gas emission will be reduced and more amount of hydrogen will be utilized. That slowly, one of the area we are not focusing for a cleaner energy was home appliance. For gas, home cooking, residential cooking purpose, the gas we are using, which was an LPG, but it was not monitored under the category of emission. It was not monitored. Only in the case of oil production, how much amount of gases, emission gas or greenhouse gas emissions was emitting from the system was done by the industrial people. After once it was sales out to the market, once we have used, it was never been monitored how much amount of fuel has been utilized and how much amount of greenhouse gases was emitting from the residential gas stove. So these are the major reason for India to implement the piping of hydrogen. So that it will be reduce that quantity of emissions. It was one of the reducing, easy to reduce on other one. Then Adani total gas project has been implemented in Ahmedabad, which was a 2.2 to 2.3 percentage of green hydrogen was implemented for 4,000 homes. It was a blending through pipeline, and such a cases will help to reduce the in the residential area pollution. So when we are taking with a pipeline network, we have to strictly follow with the leak detection, right? We are if it's a small leak, even causes a entire piping system to be damaged, and with a huge explosion, and the entire residential area will be damaged. So for the leak detection, we have a international regulations. It should be followed strongly. It should be followed strongly without negotiation or without every time it should be monitored. For this case, we have three ISO and one of the international another category was implemented European cases. So that ISO 26142 was a hydrogen detection apparatus standard was to be monitored, and the other one was a covers gases hydrogen fueling station has to be monitored under this category, under this number ISO standard. And the other one was mandating a risk assessment for a particular area has to be risk assessment has to be done on a regular basis with the ISO particular one. And the other one was a hazardous area or explosive atmosphere has to be monitored with the leak on particular ISO standards. But in the case of, so these are the production methods and hydrogen pipeline which was implemented in India, and the leak detection has to be followed on this basis. And the other one was a next. Then we are entering into the whatever after separation from the electrolysis or steam forming, we are getting into the fuel cell, which was more renewable energy and more zero pollution, which was a tailpipe zero emission, which was implementing. So fuel cell was nothing but a chemical energy, which was directly converted to electrical energy. But in the IC engine, we are converting the chemical energy into the mechanical energy, and later on we are converting into electrical energy in some cases, which power dynamo, mechanical energy, and two other energies at all. But in the case when we are converting chemical energy to mechanical energy, uh, 20 to 30% loss in the chemical energy system itself, heat losses, and the mechanical losses was the frictional power and other terms. Losses will be transmission losses, everything will be there. But in this case, chemical energy to electrical energy, only 30% of chemical energy losses will be there, 30 to 40. So easy to utilize directly from the system. And the power generation with a higher efficiency and zero harmful emissions. Power efficiency was comparatively double the time, which was 2 times higher than the IC engines. Which was IC engine was diesel engine was giving a 30% efficiency, when we can go up to 60%, 70% efficiency with the fuel cell. 40 to 60% was a fuel cell efficiency. When we are giving 40 to 60% of fuel cell efficiency compared to IC engine, then it could be more better and more renewable one. So that's why we are preferring for the cleaner energy technology with the fuel cell one. Then producing heat and mechanical work, which is in the conventional power method, which was avoided here in the fuel cell case. And the other one was a continuous power system as long as and the fuel was supplied. And the type of fuel cells was polymer electrolyte fuel cell, alkaline fuel cell, and phosphoric acid fuel cell, molten carbonate, and solid oxide fuel cells. All these fuel cells has been operated on a particular temperature, and releasing one fuel cell will release a ideal voltage, which was a, let me see, that polymer electrolyte fuel cell will be ideal voltage will be 1.17, which operating temperature of 80 degree. And when we are going with a lower temperature, the operating temperature when it varies, and the pressure of the system also varies, the ideal voltage will be dropped down, and it was an ideal voltage, and the practical voltage or that efficiency when we compare, it will be little bit lower. So it was a only one cell has a voltage of this much percentage. When we need a higher quantity or higher kilowatt, we supposed to be having a larger quantity of fuel cell stacks to be there. And the comparison of a fuel cell, when we go with the polymer electrolyte, uh, we are using a common electrolyte perfluorosulfonic acid, and the operating temperature was 50 to 100 degree, and which can be used with 1 kilowatt to 100 kilowatt, and the efficiency was 35 to 40 60 percentage for transportation applications, and other one was 35 percentage for stationary type. When you go with a it will be applicable for backup power, portable, and other things. When you go for alkaline one, aqueous solution has been used, and the operating temperature was little bit higher. And the kilowatt also similar to the polymer membrane electrolyte fuel cell. Then the phosphoric acid also, which was operating temperature was higher, and the kilowatt also higher, which will be used for the generator and distribution for generation current and local generator hub, like that we can utilize. And when we go for a molten carbonate one, which was high temperature one, and we could not able to operate on immediately, the startup time will be take more, and more amount of quantity, like solution for lithium, sodium, other things has to be needed. And efficiency also comparatively low for polymer electrolyte one. Then solid oxide fuel cell also we are having. We are using high temperature one, and we will can go up to higher kilowatt, and the efficiency was okay. But in the other cases, when we are going with all the parameter with a disadvantage, or we have to focus on one expensive catalyst has to be used, sensitive to fuel impurities. When the uh, fuel cell vehicle, right? That Toyota or Hyundai, which was using a polymer membrane electrolyte, they are using this one. If you are using a hydrogen, impure hydrogen, that vehicle will fuel cell will be get damaged. So 100% pure, which was 99.99% pure hydrogen has to be used on the particular vehicle. So without that, it will be getting damaged, right? So we have to done that one. When you see that molten carbonate, which will have a long startup time, and the phosphoric acid also long startup time. But in the case of polymer electrolyte, it was a quick startup one. Okay, these are the things of comparative with the fuel cell. So when you go with the anode and the cathode, it has a reactions. One second. Anode and cathode electrolyte, all the three cases has to be fixed together, and the fuel while the reaction was taking place. So from the hydrogen one side, the hydrogen will be flow from the anode side, and it will be once the electrical current was passed through that one, and the reaction will take place, and the proton and the electron will be separated, and so that the electrical circuit will be closed through anode and cathode. So these are the elements has been done with that one. So fuel cell efficiency was 40 to 60%. The efficiency was calculated according to that voltage of a one particular cell divided by 1.481, which was a standard theoretical value. And so that we can find that one, and higher heating value and lower heating value. With that, we have to identify, and the power density, volume, cell voltage efficiency also monitored. Cell voltage was from starting from 1.2 to 2.4. Below that, we are not able to operate the system, right? These are the graph which has been, and this one was a current research one article, which was a titanium bipolar plate. Who was done that one? Uh, Currently in India also, some of in Mumbai, one of the industry was doing the same one with a titanium bipolar plate. Let me once again. Let me show that fuel cell stack, which was a so the bipolar plate was nothing but these two are the bipolar plate. See that cathode bipolar plate and anode bipolar plate. The gaseous hydrogen will be flow from this direction, from top to bottom, and the oxygen will be flow from this direction. Anode backing. It was a one of casket, like casket material will be there. Anode backing and cathode backing, and that membrane electrolyte assembly will be here, so that electron will be flow from this direction to this direction, so that we will get the energy. We already before that we have spoke about, right, that to hydrogen will be flow from this direction. When the membrane will travel, the electrons and protons will be directed towards that one cathode, and that four electrons, hydrogen electron, protons and electrons have a reacted, and the end of the output will be water. So the input was a renewable energy sources, which was a hydrogen and oxygen. The output also water, hydrogen, oxygen, and the end result was water. It was completely renewable sources. When we are making the hydrogen production also with the renewable energy sources, it will be completely renewable one, and cleaner energy also. But the cost of production of hydrogen was very costly compared to fuel cell. So these are the case one. Titanium bipolar plate also used. There was a for polymer membrane electrolyte plate, fuel cell. There was a non-metallic based and metallic based. Other one was nickel and other things. Stainless steel also used for the making of bipolar plate. But in the recently, Mumbai, one of the industry also focusing on the titanium bipolar plate. And the area of this particular design, it was completely focused on the heat exchanger, design of a heat exchanger, which was we was well versed with the heat exchanger design, right? Um, when you are focusing on the heat exchanger, the channel depth, what are the area, this is the effective area for the fuel cell hydrogen flow area, and this will be considered as a effective area for making a fuel cell 1.48 voltage or 1.117 ideal voltage. This channel will having a depth of 1 mm or less than 1 mm only. So if it's considered as a 1 mm depth, then it will come under the category of micro channel heat exchanger. So the design of micro channel heat exchanger and the flow, in this area we have a one scope, which was the CFD analysis or flow area or designing of a heat exchanger on a particular fuel cell stack area. for a 1 mm, the Reynolds number and the laminar flow, turbulent flow, which will be different for a gaseous state. These are the area for the research to be more done on that one. It was completely not easy to focus on one because the gas which was in 1 mm channel, we have to focus and how it was doing with a better performance. If the gas flow area was not quite good, and it does not have a surface area was with not good, then the reaction will not take place better and those things will happen. So all the category will under design of heat exchangers. These are the micro channels, and the whatever the heat was production produced, it has to be again used for other purpose from the fuel cell. A fuel cell will not produce the electric energy, not alone produce the electric energy and not alone giving a water as a output. It will have a heat from the system. Once the reaction was take place, that heat will be liberated. That particular heat has to be utilized for other purpose. So these micro channels also the effective area for the uh, fuel cell things. So fuel cell means it does not the ideal voltage will be considered for only one fuel cell stack. If you consider that this is a one fuel cell, it was 1.148, and then when we are having a hundreds of fuel cell stacks, then it will give a kilowatt of power. So we have to do that number of bipolar plates and anode and cathode, so that we have to create a huge number of plate system for a polymer membrane one. This is the GIF diagram for you, how the electrons and protons are moving from the system, and how the heat has to be liberated from the system. So in the fuel cell, the research area still has to be explored. Uh, Polymer membrane fuel cell has created and utilized. Still, the heat has been liberated from the system was not explored much more. Initially, the heat has been liberated to the outer atmospheric or some kind of coolant has been used. How the fuel cell stack heat was producing, right? That has to be placed for other purpose also. These are the research area for the people. The heat liberated and other one. Fuel cell vehicles comparatively, Toyota Mira and Hyundai Nexo, which was launched in US. In India, only few ones are launched. When you go for Hyundai was a South Korean company and Toyota was from the Japan. And Toyota was still now successfully delivering very good quantity, but Hyundai Nexo was in the downfall. After in the time period of Corona, they are under the downfall. They are not able to sell the fuel cell vehicles in the US market. People are not ready to buy the even fuel cell was a greener technology, but adapting of the system and selling of the vehicle was a little more complicated. It was not easy to the conventional method to shifting of fuel cell technology or battery technology. We have to spend huge amount, and the Toyota Mira or Honda Nexo both cost of 50 to 60 lakhs it was for Indian money. When you go for an Euro American one, it was dollars of around 20 to 30,000 dollars, like that. It was will be there. But the same cases, we have a buses also in the trial range of we are using that, uh, and the trucks also in designing we are trying to utilize. India, the one we have seen, right? The Tata has been first implemented the hydrogen bus in the Noida. We can able to see that one, right? And Mercedes-Benz also done that huge capacity battery charged by the fuel cell, and they also done. In the truck, the Hyundai was done that one, which was implemented in South Korea. and the Volvo and Daimler both combined and giving a Mercedes Benz, which that also in the trial set and not completely commercialized. The problem with commercialized segment of fuel cell vehicle, we have a issue with the hydrogen supplements, hydrogen tank or hydrogen fuel to the ventas of for the people. So some of the cases we are using that fuel cell in the grid integration. Grid integration in India, NTPC has done one. They use a solid oxide fuel cell. We see that which was a solid oxide fuel cell will be having a power of 2 megawatt, 2 to 3 megawatt power. We can do it, but the operating temperature was which was high, very more than 700 degrees centigrade, and the startup will be take more time. So that will be grid for power grid we can use it. And that and the second case, ARCI has developing a fuel system which was a 20 kilowatt. Various application they are using the decentralized power was they were done. And the other study, when you go with the Toyota, they done that Olympics to promote the promote that greener technology of fuel cell systems and hydrogen. They done with the hydrogen powered Olympics. They led with the hydrogen for first time in Olympic. It was a history. Then they used the entire Olympics, which was done in 2020 Tokyo. It was a fuel cell vehicle. So the Toyota has done the marketing through this, sponsored the event and done the marketing of their fuel cell vehicles. See, they have given a buses, cars, and transported athletes, staff, everything with a hydrogen one. And the Olympic Village, that particular system was done with fuel cell, supplied electricity and other things, hot water things. And that and the torch was done in Fukushima with a hydrogen one. This was the another case study. They have tried to promote, and these are the cleaner energy and more combustible one, and they have done. Then the sale, fuel cell vehicles and other things sales. Then forecast of those one. Indian market, if you see that, it was a predicted one from 2024 to 2023. Fuel cell market has been growing for our proton exchange membrane. It was growing, and comparatively proton exchange membrane and other one, solid oxide fuel cell, because one was the proton exchange membrane was a small scale one up to 100 kilowatt, less than 100 kilowatt we can use, which was a vehicle, fuel cell vehicle we can promote. And the other one was a solid oxide fuel cell, which was the category of larger power grid area or generator, power generator, we can, government has investing huge amount. And in the globally, when we are seeing the things, how the fuel cell sales has been increasing, it was a predicted still the Indian market value was in millions USD, but in the globally terms was in billion. So we can able to see that up to 2020, next 10 years, we can able to see that the growth was fuel cell will be surely grow with the investment of a green energy technology and other systems. And challenges, the great challenge and the Toyota Nexa was done the downfall. I previously in the previous slide I told you, right? Um, the look wise it was looking like a SUV, but it was a not in the category of SUV or not in the hatchback. And the Mirai, Toyota Mirai, they have sailed with a term with a term of US give a incentives and price drop and other things, taxes reduction, and they have done that. But Hyundai done that. One of the they told we are giving a more amount of hydrogen fuel stations, and we will give you that one. But later on, once after the sales, before corona pandemic, they have done like a sales of only in California they have done that one around 2000. After then, now the sales was very drop, which was at very 200. Very small amount of vehicle was selling because of why they have failure in sales due to the hydrogen refueling station was they promised Toyota was promised with a tax reduction and other things, but Hyundai done with a hydrogen refueling station. They thought that they can implement, but it was they are not able to do that, and they are not able to give a larger quantity of hydrogen supply to the people. So the sales was down. In 2022, the data was giving it around more than 2,000 to 3,000 for a year, but now they are selling around 200 fuel cells car. So these are the drawback in US. This is only case for the US. And the globally fuel cell car was, let you see, means South Korea, Japan, and US has been done that large. South Korea, in Hyundai, in the case, South Korea was doing better, and US also doing that one. And Europe was not much focusing on the fuel cell. They are much focusing on the hydrogen and petrol hybrid vehicles. With that itself, they can able to obtain the Euro 7 emission norms. Easily able to obtain the Euro 7 emission. So easy to manufacture, and extra system, smaller system has to be adopted. Easy to implement immediately. We can implement, and in the market case, this is for the Renault. Renault, which was selling the market vehicle. I'm saying that. And Hyundai Nexo, that particular fuel cell stack system, and it was around 95 kilowatt stack plus 40 volt kilowatt battery was supplying that, and with that we can go around 5,570 kilometers, and we can able to do that one with one, and the entire system was doing in South Korea. And when we see that one, 95 kilowatt stack we have to make it means this is the engine. 95 kilowatt stack has to be produced. The fuel cell engine means we need number of cells. How many means it was around 200 to 300 cell stack has to be inside this system. Then this is the Mirai hydrogen system. That hydrogen system was hydrogen fuel cell was in the front, and the tank was in the middle, and the power was transferred to the back end, so that we are utilizing that vehicle. And the policy and incentives was EU
Siva
Green
sir,
Deal. Yes.
Siva sir, actually time is going to end 5 o'clock.
Yeah, it's only the policy incentive and other things was there.
Okay,
Then it
okay.
was
Because
over.
next section has to start 5 to 6:30. Then they are going for test. That's
Yeah,
why.
yeah, yeah. European Green Deal was one of the European user grants and standard regulations, and US heavily rely on tax credits. I told you right. The Toyota has been deployed that tax reductions and other things, but Hyundai was chosen a wrong path, and the sales was down. Future innovation. So whatever the things we have focus on, AI, still fuel cell system we are adapting, that itself very complicated for us. When in the case of AI technology was implementing, currently we are last 3 to 4 years, people are much more speaking on that AI technology, and try to implement the AI technology with our existing system. So management of a large scale electrolysis systems and real time optimization. I told you right in the previous case, the hydrogen temperature, pressure, density, everything has to be monitored with a real time optimization. When we are implementing the AI technology within the fuel cell, we can able to obtain 12% of efficiency can be improved. And the predictive maintenance and the total entire system has uh, monitored, and we can easy to go for the maintenance also. Nissan and Audi has doing AI system. AI adapted vehicle has been done, but that was not for a mass market implementation. But they have done that one. AI has been implemented in the Nissan vehicle, Audi vehicle, and they have on a trial basis, still under the research. So the overall conclusion we can see from the system, we have to, for a cleaner energy, we have to decarbonize the fuels and the system. And the next case, when we are going for a decarbonize, we have to more focus on the uh, cleaner energy, and the complete life cycle has to be analyzed so that we are on a cleaner energy systems. Okay, so whatever the possibility we are doing on a research, the complete system come under the category of life cycle analysis in the greener energy systems. Yelmala sir, the entire
Yes, sir. Thank you so
so
much.
thank you, sir.
1 minute, sir. Participant, if you have any question, you can ask. I already given the option to mic to you. So, participant, if you have any question, you can ask. Siva, sir.
Yeah.
Yes, sir. Thank you. I think one
Thank you,
person
sir.
is
Thank you
rising,
so
sir.
much.
One person is rising. 1 minute, sir. 1 minute. Sir Patel, sir, you can unmute and you can talk. Okay, sir. Shiva, sir. I think no question from participant. Thank you so
Yeah.
much for accepting my invitations and nice presentation, sir.
Thank you, sir. Thank you so much for
Thank you
giving the
so much, sir.
opportunity and
Now
everything,
we
sir.
can leave it, sir. No can
Yeah,
leave.
yeah. Thank you, sir. Thank you.
Okay,
Thank you so
sir.
much.
Okay, I will give the brief introduction about Dr. Prabhakaran Segar, sir. Dr. Prabhakaran Segar serves as the Chief Technology Officer at the BTI Ignite Exhibition Council and is recognized for his contribution in automobile engineering. He completed his PhD at the MIT Anna University as the first and youngest full-time research scholar to achieve in that shortest stipend period, and was also the first to receive the DST pursue stipend with the 73 Scopus indexed publication, including scientific reports, Springer Nature. He has made notable research contributions. He worked in Ethiopia through the United National Development Program, served as the highest paid expendable at KIOT, and has over 10 years of teaching experience, including 7 years of international. And he has delivered expert talks at IIT, NIT, and universities abroad, and MOE led with international collaborations and student exchange activities. He was selected for the National COVID-19 Summit and Africa Asia Youth Forum, and he is a recipient of the Young Researcher Award 2015. Sir, I heartily welcome you, Dr. Prabhakaran sir. Now we can take out the sections.
Yeah. First of all, thank you all for participating in this event. Personally, I want to thank Dr. Elmalai sir from Aditya University for giving me this opportunity. Thank you, sir, for inviting me. So I will start with my session, sir. So the session will be like around like 1 hour 15 minutes. So after 15 like the last 15 minutes, like we will go for the question and answer. Is it okay, sir?
Yes, sir. Okay. You
Yeah,
can
thank
proceed, sir. Yes.
yeah, thank you.
Your screen is visible, but
Yeah.
PPT it's not visible.
Just okay,
Yes,
sir.
now it is visible. Yes.
Is it
You can
visible,
make it
right?
full screen, sir.
Yeah,
Okay,
I
okay,
make it already. I made it.
okay.
So good evening, one and all. So thank you once again. So today topic is like regarding the smart electrical and hybrid vehicles, which is like AI driven innovation and challenges. So I want to make it very clear that about the each and every term around like electrical hybrid vehicles and innovation challenges. So myself, I'm just working as a Dr. S. Prabhakar Segar. I'm working as a Chief Technological Officer at the BTA Ignite Incubation Council, which is like a Session 8 company. So my work is that I'm just making like bridging between the company and the colleges. So I'm just taking some classes all over India for this electrical and hybrid vehicles, and for the startups and innovation challenges also. I'm just going many places. So today's session, I will just make it very clear that I want to make this session a little bit like a multidisciplinary. Is it clear? So I want to make it in this session like a three subcategories or like six subcategories where I'm just going to cover all the departments because many faculty members are from different departments are attending this session. So I want to make it in such a way that this session, this 1 hour 15 minutes, it will be like a multidisciplinary session. Is it clear? So, and all the slides which I'm just going to teach you now, okay, it is prepared by me. So, any doubts, okay, you can just make a note of it. At the end of the session, okay, we will have the question and answer session. So, first subtopic, okay, what I'm just making is that like a electrical segment. So, here I'm just going to cover about the fuel cell electrical vehicle, hybrid vehicles, wireless charging, and regenerative braking system for the electrical and hybrid vehicles. So I think most of the faculties you are attending the session for more than 6 days continuously, right? So today this slide I want to make it in such a way that it will be something different from other slides. So first I will just go with the electrical car. So everyone, okay, like everyone is teaching that till now, we are just electrical vehicle is a green vehicle like that. Everyone is telling, but you have to know that if I'm just taking any power from the solar, that means by using the solar panel, and if I'm just using directly for my electrical vehicle, that means I'm just going to charge for my battery. This vehicle, it's called as like a pure electrical vehicle. But anyone seeing that any electrical vehicle in this world, it is using only the solar power for using for charging the battery. I think nobody will see, right? Because you'll be having battery here, but this battery we are not charging by the solar. We are charging only by the source of like electrical power. That electrical power we are getting till now in India by burning of coal or fuel. Is it clear? So how you can tell that like this electrical vehicle is a green vehicle? We can't able to tell directly this electrical vehicle is a green vehicle. And many people are telling that okay, electrical vehicles, it's just we are not seeing any pollution. The thing is that we are not getting any tailpipe emission, that's all. But the power which we are using for the battery till now, we are getting from the external source. So in this session, I'm just going to tell some of the research areas and even some of the innovation areas where most of the faculties, those who want to do any PhD, okay, just take this as a like a project topic and try to implement that. So this is a pure electrical vehicle which I'm showing the left side. Is it clear? So why we are not able to use solar panel? That is a very important thing. The thing is that the power which is generated by using the solar panel is not that much of sufficient for our electrical vehicles. Is it clear? So if anyone want to do any research, try to focus on the solar panel because this area is under the research. Even Tesla and many companies, they are focusing on this area for doing the research. Is it clear? Guys, please make a note of it so that at the end of the session, you can ask me the question. So this is called as like a pure electrical vehicle. Till now, I'm just telling you again and again, we are not using any pure electrical vehicle. Is it clear? So second one, if you just see the side, right side of mine, many people's, okay, they're calling as a hydrogen vehicle, hydrogen car like that. But the real term which everyone has to know is that it is not like a hydrogen car. It is like a fuel cell electrical vehicle. Is it clear? Hydrogen car also is there. I will just tell you in upcoming slides. If you just see here, this is called as like a fuel cell electrical vehicle. So what is meant by fuel cell electrical vehicle? That is a very, very important thing. So like I know the last presenter also, he just teach more about the fuel cell electrical vehicle. If you just see here, like, okay, Toyota Mirai, if you just see here, if I'm using the hydrogen directly into the engine, okay, then it is called as like a hydrogen engine. Is it clear, guys? When I'm just using hydrogen directly into the engine, it is called as like a hydrogen engine or hydrogen IC engines. But till now, we can't able to use a hydrogen directly into the engine. Is it clear? So anyone knows what is the reason that why we can't able to use hydrogen directly into the engine? Because everyone has to know that this hydrogen vehicle is one of the technology which came back before like 20 years back itself by BMW. But the thing is that many problem occurs in that vehicles and they produce around like 100 hydrogen engine vehicles and most of the vehicles, okay, causes some explosion. So because of that reason, the BMW they stopped that hydrogen vehicles and they're just focusing on another sources. So what is the reason is that this hydrogen is one of the smart gas. Okay, so in our engines we are using some valves, right? I'm telling you one of the reasons. Engine valves we are using, right, which is like inlet valve. I think everyone knows about the inlet valve. the very important thing about the inlet valve is that the fuel has to come inside and it has to be like a one way. But this hydrogen gas is very smart gas. It will come, it will touch the engine heat, which is like a combustion heat, which is inside the combustion chamber. And before closing the valve, it will come back. So the explosion will cause. Okay, so most of the researchers, please note that if you just focus on the valves, okay, we can able to implement the hydrogen fuel in the engine itself. Is it clear? So here, if you see here in this fuel cell, what we are doing in the fuel cell is that first thing, where we are taking the hydrogen, that is a very, very important thing. Till now, we can able to take the hydrogen from the water, which is like H2O. Okay, we are just during an electrolysis process, we are just getting the hydrogen. So that also, if you just see many places, they're just focusing on the solar panel. Again, I'm telling you that with the help of the solar panel alone, we can't able to use the electrolysis process. Is it clear? Again, it is burning of coal or fuel or some other extra external energy we are using for making the electrolysis process. Is it clear, guys? Again, what we are doing is that we are storing in the tank. Here, this is also one of the area of research because hydrogen is like a normal tank. We can't able to store it. Okay, so it needs some heavy storage tanks for storing. So here, guys, just try to focus on this area to store the hydrogen. Also, is one of the latest research area. Next, hydrogen has to be distributed to the gas tank, right? That means like a hydrogen gas tank. It's like a fuel station. Okay. So here you have to know that another thing where the distribution also is done by the petrol engines or like a diesel engine. Mostly we will be going for diesel lorries, right? So here also the energy is lost. So again, we are just storing in the fuel gas station. Again, here if you just see in this vehicle, we are storing in the tank of the hydrogen. Okay, this is like a hydrogen storing gas. From here, we are not able to give directly to the engines. Is it clear, guys? We can't able to give this hydrogen power directly to the engines. Instead of that, what we are doing is that again we are doing the electrolysis process. I think if, the slides are visible, right? Elimalai sir, slides are visible, right? Sir, yes, sir, visible, sir. Yeah, okay, you can proceed. Yeah, thank you. Thank you. So here, what is happening is that the hydrogen from the anode, it is just passing to the cathode. It is same like a battery. Okay, so here, what is happening is that we are able to get some electricity. Okay, when we are, it is also same like the battery. What is happening inside the battery? So here, the one more research area is that here the electricity. We can't able to know how much of electricity is produced till now. It is under the research. Some researchers are telling that we know how much of the electricity is producing like that. So till now, the heat also which is produced in this area, it is under the research. Okay, so anyone is doing like mechanical engineering, the thermal management of this area also is under the research. So just try to make it in such a way that you have to do some research in these areas. After this, we are just storing in the battery. Okay, here. After in this battery, we are giving to the motor. So this one is called as a fuel cell electrical vehicle. Is it clear? We are not using the hydrogen power. We are just using this hydrogen power to the charging of the battery. From the battery, we are giving to the motor. So this is called as a fuel cell electrical vehicle. I think everyone is clear, right? So here, we are just losing, the energy loss is taking place in three places. First is here, conversion. Second is like a, we are just making transportation. Third one is that here again, the third stage where we are converting the energy again for the battery. Here also the losses is very, very high. So what Toyota or many companies are planning is that they're making like onboard diagnosis, like it's like a onboard kit. It is like a onboard generating kit of the hydrogen with using of ammonia. And I think till now it is also under the research, so that there is no need of these stages. Directly the vehicle, okay, from the hydrogen, it will create some hydrogen gas and it will directly go to the motor, battery to the motor. Is it clear? So now, the very important thing is that many people have some doubt. Sir, what is the problem with the hydrogen engine? Can we go for the hydrogen engine? Okay, that may be the like many people they will ask this question, right? So now you have to know that there is one good news. In future, okay, many people will try to use directly the hydrogen engine, where from the hydrogen fuel, okay, directly we are giving to the engine. Is it clear? It is not a electrical motor. It is the engine. So in such a way that in future, don't think that electrical vehicle is the future or hybrid vehicle is the future. We don't know what will be the future, guys. That is a very, very important thing when you're just doing any research. Okay, it's everything like it's like a technology transfer. We don't know, okay, when the technology transfer will take place. So this is one of the hydrogen fuel vehicle, which already launched by BMW. But again, if you see the CEO of Toyota, 16代目の okay, he is going to introduce this hydrogen engine in future, so that maximum by 2 to 3 years you will get this engine for all the vehicles. So anyone knows what is the exhaust if I'm using hydrogen? What will be the exhaust? Any guesses? It will be like a H2O. Okay, if you use hydrogen as a fuel, the exhaust is nothing but it's like a pure water. So you can even drink the water. So that is the advantage of the hydrogen vehicles. Is it clear? But here we are not using any battery from the tank directly. We are sending to the engine. Is it clear? So this one everyone has to know. So here, the very important thing is that why people are moving towards engines to electrical vehicles. That is a very, very important question everyone should ask. When anyone is taking the class, everyone should know this. Why people are moving towards electrical vehicles rather than IC engines. But till now, I think if you go for any colleges, college bus is like IC engine, or many places. Till now in India, around like 90%, I can say that 80 to 90% still now we are using the IC engine only. But we are telling that electrical vehicle is the future. Electrical vehicle is the future. The thing is that we can't able to make the electrical vehicle directly. It will take some time. Minimum, like it will take 30 to 40 years to make all the vehicles as a electrical vehicles. Is it clear? Why people are moving towards the electrical vehicle? Don't think that it's because of the pollution or because of there is no noise. The very important thing is that why people are moving towards the electrical vehicle is that because of the efficiency. If you see the efficiency of here, the electrical vehicle efficiency is more than 80 to 90%, which is like maximum percentage. In IC engines, still now we are getting around like 40 to 42%, which is like a fail mark. We are not getting even up like more than 50 marks. But electrical vehicles, it is giving like more than 80 to 90%. So this is the only area of the research where most of the people are moving towards the electrical vehicle. Is it clear? So I think everyone knows about these engines. I told you, right? If you want to implement this area, the hydrogen directly into the engines, just try to focus on these valves. This is one of the area of the research. So any researchers, please make a note of it. Okay, so this is one of the research in the Japan. If you just see this technology, I think everyone knows that in train, it is also electrical vehicle. The stopping time of each station is 1 minute, right? So in China, they want to minimize this timing also. So in future, they're building a train which is called as like the train won't stop. Is it clear? So this is one of the new compartment. When the train comes, okay, it is having another one compartment at the top where people has to like if they want to come to this platform, they have to just go to the top of the train. So here the very important thing is that timing. So the train won't stop. It is also electrical vehicle. It will attach the new compartment. It will detach. You just see it attaches the new compartment. It detaches the old compartment. Just see here. So in this area, what is happening is that there is they want to minimize that 1 minute, okay, in the railway station of each station. Basically, just see how much timing is very, very important for this people. So this is one of the thing, okay, where train won't stop. Is it clear? So this is some of the projects from the students. Those have done the project in the electrical vehicles.
Yes.
So advantage of the electrical vehicle is that it can rotate up to like 360 degree. And the very important thing is that parking. Okay, it is very, very good for the parking purpose. Okay, easily you can park the vehicle. You can see this vehicle. Is it clear? So it is like a crab walk nowadays. Even in Hummer also they're doing this technology, which is like a crab walk. Okay, this vehicle also is like electrical vehicles. So we have advantages of the electrical vehicles. We have some disadvantages in the electrical vehicles. The thing is that if there is any disadvantages, we have to take that as a research, and we have to do some research on that area. Is it clear? So now I think you will get some clear idea about the battery vehicle, about the fuel cell electrical vehicle. So battery vehicle, the very important thing is that battery will be there, and it will be directly, we are sending that power to the motor. Fuel cell, we have tank where we are having hydrogen. From the hydrogen, again electrolysis process, we are like same like electrolysis process will be there. Again, we are charging the battery, and from the battery, we are giving to the motor. Is it clear? So this is the difference between the battery vehicle and fuel cell electrical vehicle. Is it clear? I think everyone understand in this. So here, the very important thing is that this area, it is called as like a cooling. So this area also is under the research. So anyone is doing some thermal engineering or mechanical engineering, even electrical peoples also, you have to know that battery also will get heated. Okay, even your motor, okay, motor also will get heated. So here the very important thing is that in olden days we are not using any like coolants or like radiators for the electrical vehicles, but nowadays we are using coolant plus radiator for the electrical vehicle. And you have to know that the same coolant on the same radiator which you are using for the IC engines, we are using for the hybrid vehicles also. That means the engine with electrical vehicle, that means motor also, we are using the same radiator and same coolant. So this is very, very important thing. And this is also under the area, research area. Okay, this is also like one of the area where you have to do some research. Till now, it is not that much of proper, even though we are just taking some heats from the motor or from the engines or from the battery. This area also is under the research. So you guys has to do some research in this area. Okay, so now the another technology, the innovation areas, which is in Tesla they're doing. It's called as like a bi-directional. This one is called as like a bi-directional area in the electrical vehicle segment. So if you just see this bi-directional, for example, I think everyone knows what is the voltage of the houses which we are using in India is that it's around like 440 voltage or like 400 like 420 to 440 voltage, right? Anyone knows that what is the voltage which we are using for the electrical vehicles? It is like more than nowadays, like we are using more than 650 to 700 voltage. So this area, it's called as like a bi-directional, where we are charging the electrical vehicle in morning. Okay, if we are having some excess of energy, okay, what we are doing is that we are just giving back to the houses. Our car will act as like a generator. Okay, it will just give some charge to the house. Sometimes, if I want to sell my electrical power, I can go directly to the government. I can give my electric power to the government and I can get the money. This is a second thing. Third one, this very, very important thing is that many people knows that why in many places we are not using the electrical vehicle is that because of this charging is one of the issue with the electrical vehicle. So if your vehicle is having some charging, that means your vehicle is having full charge or your battery capacity is very good, by DC to DC converter you can give charge from your car to the another car which don't have the power. Is it clear? So in that way also you can do the business. So even nowadays our students from BTA Ignite Incubation Council also, we are focusing on this area for making as a startup. It is not like a battery swapping technology. It is also one of the mode where we are just giving the power from the battery, like means bigger battery to the smaller. It's like a power bank. Okay, this is also one of the area where you can do the startup. So here, the another thing in the research area is that BMS. So where AI is technology is involving, that is a very, very important thing. Everyone has to know that. Sir, where is AI? You are just using the AI. So here, if you see in a vehicle, most of the batteries which we are using for cells, if we are using as a cell, okay, in a batteries, it is like a cell, like a everyday battery, a AA battery cells only we are using in a electrical vehicle. So here, the very important thing is that if one battery, okay, if it is not working properly, okay, if the one battery is not working properly also, the issue will happen. So here the AI is acting very in a very good way, so that it will be monitoring the vehicle each and every time. Is it clear? Is it clear, guys? So AI is monitoring each and every time our vehicle, each and every battery cells. So in that way only, the safety of the vehicle will be very, very good when we are using some AI technology of the like safety precautions. So what are the very important things of the customer's point of view? That is a very important thing of implementing the electrical or hybrid vehicle is that cost, charging time, battery range, your infrastructure, and like a vehicle size on a type. So here, to my knowledge, the very important thing is the battery range. Many company people will tell that the vehicle will be giving some 500, 600 like that. But when you just buy any electrical vehicle, it won't give 500. It will be like 200 or 300 only. And the infrastructure, this is a very, very important thing. Everyone has to know that without infrastructure, we can't able to implement the electrical vehicle directly. Is it clear? So this is one of the like before like 3 years back, I worked in like one of the Africa continent. So this is one of the projects of the students where this is one of the normal projects in India. If you see this vehicle, it is like a Bajaj Auto where they're just using some solar panel above that, and they're using some motors with a battery. So here they're just converting this vehicle as a hybrid vehicles. So everyone knows about the hybrid vehicles, right? About the hybrid vehicles. Before going to the hybrid vehicles, I'll just tell you one more research area, which is like a suspension. I just take some empathize. It means like we are just keeping some entry for the most of the uh, people, those who are riding in the electrical vehicles. Everyone is complaining that, sir, when I'm just riding my electrical vehicle, I'm getting my back pain. So most of the electrical vehicles are like a retrofit. So the suspension system of most of the electrical vehicles also, to my knowledge, it is under the research. So guys, try to focus on this suspension system. Okay, most of the suspension system is creating some issues with the electrical vehicle because when you're adding the battery to the vehicle, the electrical vehicle is more heavier than the normal IC engine car itself. So just try to focus on this area. Is it clear? So everyone knows this term, right? Which is called as like a hybrid. So I think everyone knows that even the coronavirus, we will call it as a like a hybrid virus because like after you are taking the injection also, the virus has a tendency of attacking you. So this is a term which is called as like a hybrid mode. Okay, which is called as a hybrid. So what is meant by hybrid? So what is meant by like a hybrid vehicle? So everyone has to know. Myself, like I studied from MIT Anna University. So before 10 years back or like before 15 years back, we are not doing any project in like electrical vehicles. Every project will be in engines. After like the EV revolution came, now most of my juniors, they're doing research on electrical vehicles only. They're not focusing on IC engines. So here, this hybrid vehicle technology is there. You can see the companies those are having the IC engines, they only implemented this technology which is called as a hybrid technology. Is it clear? There is no hybrid vehicles in Tesla. There is no IC engines in Tesla. This thing everyone has to know. Is it clear? So what is the main difference between electrical vehicle and hybrid vehicle? So in electrical vehicle, we'll be having only the motor and batteries will be there. The power from the battery will go to the motor, the vehicle will run. Here, hybrid vehicle means it is the combination of both. We have motor, we have engines, we have battery, and we have fuel tank. So we are just getting the power from both the things. So what is the advantage of this hybrid vehicle is that we can go for long distance. But what is the drawback of the hybrid vehicle is that the cost of this hybrid vehicle is that you are buying a IC engines plus electrical vehicles. Is it clear? And many people they will ask one question, sir, in my shift car, sir, I'm having one battery. So can I just call my vehicle as a hybrid vehicle like that? Many people they will ask. So the thing is that If you are having battery alone, your vehicle can't be a hybrid vehicle. The main thing of the hybrid vehicle is that you should have two energies. Okay, two independent energies should be there. Power should be there where it has to drive the vehicle separately. Basically, it has to drive the vehicle independently. Then only this vehicle is called as like a hybrid vehicles. Is it clear? So here battery also can able as a tendency of move the vehicle. Engine also has a tendency of moving the vehicle. So then only it is called as like a hybrid vehicles. And don't think that only petrol and battery is considered as a hybrid vehicles. Any two sources. Okay, for example, if I'm using some solar energy, if I'm just using any nuclear power, that vehicle also I'm calling, I can call it as a hybrid vehicle. Is it clear? Is it clear? And here, if you just see the difference between like hybrid and IC engines and the electrical is that, and there is one more option, one more like feature which is called as like plug-in hybrid. So these things, I think everyone, I think you learned in the previous session. I'll just tell you some of the some like things that you can see the emission. Even in IC engines, you will be having emission, and hybrid also will be having the emission. Even plug-in hybrid also, the emissions will be there. Here in the electrical vehicle, I told you right, we are not calling as a like a emission, but you can't see the tailpipe emission. That's all. Don't think that an electrical vehicle is not causing any pollution. Electrical vehicle also is causing a pollution, but it is like it is not visible. That's all. So here it is called as like a no tailpipe emission. Is it clear? So these are some of the fuels which is available in India and all over the world for the hybrid vehicles. So here the very important thing is that some countries are using alcohol also as a fuel, but in India we are not using alcohol as a fuel because most of the alcohols okay human beings are consuming. So we don't want to give to the vehicles. But in some countries we are just using this alcohol as a fuel. Even ethanol also is one of the very good fuel for the vehicles. Okay. So these are all some of the fuels which are using in many vehicles. So in hybrid vehicles, the very important thing is that I will just go for the case studies. I think for everyone it's visible, right? So now I just tell you the advantages of the hybrid vehicles. One, two, three, four. So in the case one, if you just see where we are, for example, if there is any traffic or if you want to go in a slow speed, here the AI technology will be using. Okay, we are just using the AI technology in this area also where AI will analyze that whether you are going in a slow or whether it's like a traffic or like because of the cloud also we are connecting with that. So here what will happen is that automatically your vehicle will be in electrical mode. Is it clear? Your vehicle is in electrical mode. So what is advantage of this is that you won't get any tailpipe emission. So in that place alone, your vehicle will be acting as a electrical vehicle. Is it clear? So this is the mode one. So when you're just going in a slow speed or when you're going in any traffic area, by the AI, like we are just already have some AI assistance modes available. So it will just detect the speed of the vehicle and automatically it will shift from engines to electrical vehicle, electrical power, like a pure electrical power. Okay. So here, this again category, if you just see here, this again case, when your vehicle is moving in any hilly stations. Okay, here the very important thing is that because of the AI, automatically detects that okay you're going in a hilly station. So it will on the engine also, and you'll get the power from the motor also. That means from the battery also. So when you're just going for acceleration or like a uphill, the vehicle will be running with both the powers. It is like a petrol or even like a diesel plus electrical power. So this is very, very important for the hybrid vehicles. So hybrid vehicles will give you very good performance in the hilly stations. Is it clear? It will be having very good performance in the hilly stations. So the third one is that when you're going for the constant speed, so sometimes your vehicle will be running with the IC engines. After that, it will automatically stop. And then what will happen is that your vehicle will be running with the electrical power. So in that condition, your petrol engine will act as a generator and it will charge your battery. Is it clear? This is the case three. So the fourth one is very important term where many people are having doubts. We are using it's called as like a de-accelerate or downhill, where we are using the technology which is called as like a regenerative braking system. So here, what will happen is that the vehicle will be completely changed to electrical mode. So many people will have the doubt, sir, why we should not switch off the engines while you are coming down in a hilly station. Most of the IC engines people they will ask, because nowadays the steering system, braking, everything is comes under the power brake or power steering. Okay, if engine is not on, you won't get any power for the brake or for the steering, because everything will be activated only by the pump. So here the thing is that even the pump will be activated by the electrical power also. So here the vehicle will be completely the electrical power. So what will happen is that once if we come down here, this is the area where most of the people will apply maximum brakes. Okay, so that is why the term is called as like a regenerative braking system. So what will happen is that I'll just show you what is meant by regenerative braking system. So this is called as like a regenerative braking system. So many people have some confusion with that term, which is called as regenerative braking system. Means they're thinking that we are getting some energy from the brakes, but we are not getting any power from the brakes. Is it clear? We are getting power from the motor. So when you're just going in a forward direction and when you just apply the brake, what will happen is that the power, okay, which is lost during that braking time, it will be again regenerated. Again, it will come to the battery. So in that way, your battery, that means your battery performance will be very, very high. But the problem of this regenerative braking system is that again and again, when you're charging and discharging, your battery life will get decreased. So this regenerative braking system also is one of the area of research where nowadays most of the companies, they're not using this regenerative braking system. Is it clear? Is it clear, guys? This area also under the research. Now, most of the companies is not using the regenerative braking system because it is because of this technology, your performance. That means you can go for a little bit more kilometers. But the problem is that your lifetime of the battery will get decreased. Is it clear? So this is the one of the area. So now I'll just tell you how your hybrid vehicles will work. This is the area. Just see. I think everyone is seeing, right? So when a vehicle is coming from like along, it will use the power of the engine. Okay, once it comes reaches the city, then your vehicle automatically to have the conversion of electrical power. Where because inside the city you'll be using for the electrical mode, correct? Because you will be traveling at a less speed. So you can see here. So once if you cross the city, okay, if you are going for some hilly stations, again your vehicle automatically it will be converted to a hybrid power. I think now everyone got right. And this all the things it is automatically done by the power of AI. Is it clear? We are not any shifting anything. Okay, so I think most of the hybrid technologies everyone knows that. So I will just also tell you some types. I think everyone in the last class itself, I think everyone knows this powertrain arrangement. We have different types of hybrid systems, series, parallel, like that. So now I will go with some of the latest technologies in the hybrid vehicles, or with the IC engines, or with the like electrical vehicles. So this BMS is like called as like a battery management system. Here, this all like every vehicle nowadays, we are using this technology. Okay, each and every time we are checking the battery range, whether any battery problem is taking place, and this also we are just implementing AI in this area nowadays. So with your mobile phone itself, with the cloud technology itself, you will know that what is the temperature of the battery, everything. Is it clear? And the very important thing is that no need of touching the vehicle. That is a very, very important thing. In olden days, if you see anything, we have to go to mechanic shop, we have to check it everything. But nowadays, everything is connected with the sensors, so you'll know everything. Okay, without touching the vehicle. So this is also one of the research area which is called as like a wireless charging. So here, in future, what will happen is that I think everyone is paying money for the fast tag, right? So in future, what will happen is that you have to pay money for the fast tag for your petrol or diesel cost also. That means your vehicle, the road is full of electromagnets. You can see here, the road will be full of electromagnets where there is no need of battery. Is it clear? I think everyone knows that electrical vehicle means till now everyone is thinking that with the battery only is like a electrical, correct? Your train also is electrical vehicle, but you don't have that much of battery. That battery is used only for running the fan or light. Is it clear? So your electrical train is taking power from the top. Here, your vehicles are taking power from the bottom. So there is no need of battery in future for the electrical vehicles. So this is also called as like a wireless charging. And already this technology, okay, we are started implementing in Israel, where your roads are like digged up and we are having the electromagnets. So each and every time, okay, when your vehicle is going in that road, it will be charging automatic. That means like a when there is any less power. If you want, you can keep even battery. If you don't need any battery, no need of batteries also. Directly with the electrical power, your vehicle will run. Is it clear? So this is also called as like a wireless charging, where this area also is under the research, guys. Even for mobile phones, you can see that till now people are putting charge only with the wire. We are using only with the power of the wire. We are not using directly with the like a wireless charging, because this wireless charging also is under the research. Till now, we can't able to get the proper charging. Okay, the power transmission also is not that much good. If you see here, transfer also won't be that much good. So you have to know that this area also is under the research. Is it clear? This is the regenerative braking system. How it, for example, when you apply the brake, don't think that we are getting power from the brake. Again and again, I'm telling we are getting the power from the same motor. Okay. So many people will ask the doubts that how many years my battery will come. Okay, nowadays like they're giving warranty up to like 8 to 12 years. But to my knowledge, it is like you're replacing a new vehicle, because battery cost is a little bit high compared with the like your vehicle itself. Okay, so this is also is one of the areas. So battery is very, very important for the electrical vehicles, guys. So just try to do some research in this area, and I will just tell you what is the battery, what is the future battery we are going to use. Okay, till now this battery is also we are getting charged only from the electrical power. That means from the fuel, burning of the fuel or coal. So now I will go for the second subcategory, which is called as like electronics. So without the electronics, you can't implement the AI technology also. This is a very, very important thing you have to know. Okay, so here, if you see this all-wheel drive, so everyone knows about the four-wheel drive, right? Many cars, okay, there. I think most of the IC engines people they will know the four-wheel drive. Now most of the vehicles we are using even the all-wheel drive. So if you just see this all-wheel drive, what is the advantage of this all-wheel drive is that it will be having the sensors. Okay, so it will be connected with the wheel sensors. Okay, we have some wheel speed sensors also available. So this is a ECU. So in that area, each and every time, okay, for example, in a four-wheel drive, it is like a manually operate. You have to operate by the manual. Okay, but here it is automatically operating, and we are implementing some AI technology in this. So each and every time, the power transmission inside the vehicle will be automated. Is it clear? No need of using any manual switches or anything. Depending upon the road conditions, okay, the electrical vehicle or even hybrid vehicles or even IC engines, okay, it can detect about the road conditions, okay, and it can transfer the powers to the other wheel. Is it clear? Is it clear, guys? So this is mainly of the ECU which is present in the vehicle. So even this also one of the like Audi e-tron. Okay, it's like it is like IC engines, but even in Audi e-tron or some of the electrical vehicle in future, if we see this four-wheel drive will works. Okay, for example, when you want to take a right turn or a left turn, okay, there also like this. If you just see the distance above this inner wheel will be short and outer wheel will be more. So here, what we are planning to do is that okay, the because of this reason only we are using differential in most of the vehicles, but mostly in electrical vehicles, what we are doing is that when we want to take a turn, okay, the right side, the power transmit to the right side is for example here, it automatically will reduce, so that there is no need of differential in the vehicles in future. Is it clear? When some of the electrical vehicles we are using some differential, but we can able to eliminate the differential when we are sending the power when it is like low speed here, we can give that means less power to the inner wheels, more speed, more power to the outer wheel also. The vehicle easily it will take a turn. Is it clear? So this is also one of the example of the dynamic steerings where nowadays we are using in most of the vehicles, even in hybrid vehicles like that. You can see here, not even a 0% diversion will be there. Just see this vehicle is going in a reverse direction. Just see, not even a single diversion is there. Just see how much electronic precisions we are using nowadays. That is why sensors plays a very important role in the AI technology. Without the sensors, we can't able to implement anything. Is it clear? So this is one of the latest technologies in the digital lighting system. So now Mercedes Benz. Okay, this lighting system is called as like a digital lighting system, which is implemented in the Mercedes Benz. If you see this, this is like a voice recognition system. So when you just talk inside the vehicle, it's like voice recognition. If you just tell, guys, please stop. Okay, it will be just reflecting outside. This is one of the latest area in the innovation of the lighting system from the Mercedes Benz. It is one of the latest area. So guys, when you just focus on research, make sure that it should be like a multidisciplinary. Even though it is like electrical or hybrid or any other technologies, don't focus only on one area. Just try to focus on multidisciplinary areas. Is it clear? So this automatic emergency braking also, we are nowadays using the AI technologies in this, where it is comes under the driver assistance. So I think everyone knows that in many places they're making as a zero in many roads. In olden days, I think before 1 year back, many police officers they make on banner which is called as zero. That means like they want to make it like a zero accidents. But in spite of that, also many accidents occurs in that banner itself, near the banner itself, because we can't able to control all the vehicles, and in all the vehicles in India, we don't have the same technology. So this is called as like automatic emergency braking system. Even you can see this is one of the example where here the vehicle automatically it stops. Okay, just see here the driver, okay, he didn't apply the brake. The brake is applied by the sensor automatically. So nowadays AI is using everywhere where it is giving some assistance for us. Is it clear, guys? So this is also one of the latest area where most of the people, you know that most of the cars which is available all over the world is having only limited colors, right? Uh, White color, black color, or sometimes it will be like a blue color or cement color like that, right? Ash color. So now this technology also is going to come. Already it is launched in 2 vehicles where it is called as like a, this technology is called as like a color changing concept. So already it is implemented in BMW and in Toyota cars. So if you just see this video, you can keep wallpaper in the vehicle. Okay, you can change the color of the vehicle, but the thing is that your vehicle itself is made up of like a cell phone panel. Is it clear? Your vehicle itself will be like a cell phone panel, so you can keep your wallpaper in the vehicle every time, depending upon your shirt color or dress color, you can match your vehicle. Okay, and already it is implemented in 2 vehicles, but in India, I didn't see this vehicle. Okay, but this technology is already implemented. So just try to do some area, research area is also open in India for this sector. Okay, so this third subtopic where I'm just going to focus is that aerodynamics. So this is also one of the very important area where everyone has to focus in this area. So why aerodynamics is very, very important is that when you want to go any high speed, okay, nowadays everyone is want to go for a speed, right? Everyone want to go for high speed. So here aerodynamics is very, very important. So without aerodynamics, okay, nowadays you can't be able to implement anything. Is it clear, guys? Is it clear? So aerodynamics is like a smart work. So if anyone wants to focus on the area of hybrid vehicles or electrical vehicles, guys, try to focus on aerodynamics of the vehicle. Okay, if your aerodynamics is not good, your vehicle, okay, even though you're having many technologies, your vehicle can't able to go at high speeds. Okay, so here you can see many electrical bikes or even IC engine bikes. Okay, they're focusing on the aerodynamics. And nowadays, the very important thing is that even helmet, okay, even visor, everything. So nowadays, aerodynamics, you have to focus on 360-degree. Is it clear, guys? 360-degree of your vehicles, you have to focus on the aerodynamics. Is it clear? And this hybrid vehicle technology itself, we are getting from the racing only. Don't think that hybrid directly come to the market. Hybrid technology, okay, we are using in most of the racing cars and racing bikes. From there only we are getting this technology. Okay, and this going the Jesco vehicle, okay, why I want to show is that just see, it's not the technology, that means not the engine. Many people will think that if the engine is very good, we can go for high speed. It is not because of the engine, it's because of the aerodynamics. Is it clear? You can see this sharp tail, it's called as like a vortex deflector. If it is not there, your rear glass will break up if you go for high speed. So nowadays you have to focus on the material, aerodynamics, everything is involved when you want to make any research. Is it clear? So this car also is going for high speed, and here nowadays the segment many people are seeing e racing also, electrical vehicle racing. But the only problem with the EV racing is that you won't get any noise. Okay, it will be very silent. Okay, so most of the technologies which we are using for our conventional vehicles, we are taking from these places only. Is it clear? Just see the cornering.
Nanu or Nanu is falling.
Just see the cornering. Ma'am, please mute yourself. Yeah.
I muted.
So this is also just see here. This tires, everything also we are going for the aerodynamics purpose. Even the materials which we are using also, it's like aerodynamics. Okay, and this is also one of the latest area. Elimelisa, please mute yourself. Thank you. So this area, it's hyperloop. I think Bangalore to Chennai, they're planning for 30 minutes. So this is also one of the latest concept, and this is also like an electrical vehicle, guys. Everyone has to know it is like a train. So how this hyperloop is working is that, yeah, it is like a concept of Tesla. Already they started implementing in Dubai, and even in Gujarat also they started implementing. But I think full-fledged till now it is not used. This is like a tunnel where there won't be any air will be there in this tunnel. So all the air will be sucked outside. So it is like a vacuum. So inside the vacuum, they're using this electrical train. It's like our metro train. So if you just see the speed of this train, it will be like starting itself 1,500 kilometers per hour. Is it clear? So in future, you believe or not, your son or your daughter, they will go to America in morning, evening they will come back to India. You believe or not? This will happen and you will see this technology. Okay, you guys, everyone will be witnessing this technology. So this technology is called as like a hyperloop concept, and many colleges, okay, they're using this. They just started doing some research in this area, and many like top institutions like IIT Madras, they're focusing on this area. Okay, hyperloop concept. So the vehicle just see starting itself, it will go like it will reach like 1,500 kilometers per hour, which is more than your flight speed, guys. So this is one of the research area where Tesla and many companies they're focusing. So just try to focus in this area where the only issue to my knowledge they're facing is that like a breathing issue because of the high G force. So just try to focus on this area so that it will be one of the very good area. So now I'm just going for this fourth subtopic, which is like IoT. I think everyone knows about the IoT, right? Which is like Internet of Technology, Internet of Things. So here we are connecting everything with AI nowadays. Okay, AI is dominating in this area. So first topic in the IoT is that it is called as like an intelligent transport system. So if you just see here, in future, every vehicle will be connected with AIoT. So this thing everyone has to know. It is different from IoT. It is called as like a AIoT, artificial intelligence of things. Is it clear, guys? It is called as like a artificial intelligence of things. So here, what is happening is that you will know how many vehicles are coming around your vehicle. You will know where is the traffic, everything before itself, and it is like a V2V. That means a vehicle to vehicle connection. So here, if you're just coming, any other vehicle is coming in your area, that means it reach your zone. So you can communicate with one vehicle with the other vehicle. You can tell him that I'm planning to come in right side. Don't come in right side. So here many people will have some doubts, sir. What will happen if I know some language and he knows different language? Even it will be like a Google translator will be available. So in such a way that you can communicate with one vehicle with other vehicle. You know how many vehicles are coming around you, how much speed it is coming. So because of this AI technology, okay, in future there won't be any accidents. Okay, and one more question many people will ask is that, sir, when I'm going in a vehicles, some police officers are there. They're catching only particular vehicles for checking that whether they're having a license or insurance like that. Don't worry, guys. In future, because of this AI technology, no police officers will get the job. You believe or not, only the police officers, many peoples they won't get the job. I'm not telling in a good direct like wrong sense. If AI is dominating human beings, we have to dominate the AI. That's all. We have to know better than AI. So here, each and every vehicles, okay, it will be monitoring by the AI technology. So if any vehicles is not having, for example, if they are not renewing that insurance, automatically the vehicle will be detected and they will send the fine for this vehicle. Is it clear? So in future, there is no need of police officers. Everything will be like a
Imagine.
monitored. So this is the second subtopic, which is called as like a brain to vehicle technology. So here it is also one of the concept from the Tesla. And with the, like, I think Nissan also is doing this technology where in future, they're going to connect your brain with the vehicle. It is called as like a brain to vehicle technology. So they want to connect your neurons with the vehicle. Is it clear? Is it clear, guys? So here what will happen is that your vehicle will be very more sensitive. So if you're planning to think in the right side or left side directions, by the thinking of the like neuron will transfer the informations to the vehicle, so it will go. So many people they'll ask, sir, what if I'm thinking something like a negative way? So for that reason only till now it is under the research. Future this technology also will come into the market, and this research also is by doing Tesla and Nissan is doing this research. Is it clear? So the third one is very important thing, which is called as like active health monitoring, where it is also connecting with the AI. So now if you just go and sit inside the vehicle, you will be monitoring 24 bar 7 inside your vehicle. For example, in future, if you are more than 60 kg, okay, I'm just telling as an example, your vehicle itself won't start. It will tell you that please go, reduce your weight and come. Then only you are fit for your vehicle. So like that, AI will be dominating in such a way that in future it will be monitoring each and every time. If you are going to get some heart related issues or anything, the vehicle automatically it will stop and it will just give the information to the local ambulance, local police station, even your relations, everyone. Is it clear? So it will be detecting each and every time. So this is one of the live example you can see here. Each and every time it will detect you, your eyes, everything. And guys, I will tell you one very important thing. This technology in future, it will be implemented in the classroom also. So if any students are sleeping, okay, it will be marked as absent automatically. Because most of the students, they will sleep in afternoon, right? So it will be marked as absent automatically. So this is not only for the car, the technology is common for all. Is it clear? Just see how much we are going for something advanced things. The technology is common for all. Okay. So I think everyone knows about this autonomous vehicle. AI is dominating like anything. Even our drones or everything is like autonomous vehicle. Even our flights also, we are calling as a like a autopilot only. So here in future, you believe or not, guys, there won't be any Uber drivers because I think I'm from Bangalore. I'm just working in BTA Ignite Incubation Council. When we are booking any vehicles for Rapido or Ola, what will happen is that King is asking 50 rupees extra. king is asking like 100 rupees extra, like that, it will be messaging. Okay, so if you believe or not, in future there won't be any king or any queen will be there. It will be like fully autonomous. So you can just book the car. Okay, in future there won't be even a steering also. So you can go inside the car. You can just mark wherever you want to go. The vehicle automatically will take you to that place. So there won't be any driver. So just inform to the drivers if they're asking some extra money. There won't be any job for them after like 5 years from now. Everything will be like autonomous. But the problem with this AI technology, like with the sensor, is that you should have the proper internet connection. That is a very, very important thing. And you should have some very good electronic systems. If it is not there, you can't able to implement any electrical or any like latest segments in this vehicles. Okay, and this is like an electrical vehicle, guys, which already implemented in Tesla. But till now, they're struggling with making the vehicle. Some places in US already it is implemented. Okay, but in India it will take some time. Okay, so the fifth one, which I'm just going to tell about the structure. So that is why I'm telling this um, 1 hour session, 1 hour 15 minute session. I'm just going to teach you some of the latest things, innovation things which is happening and which is like a multidisciplinary. You should not focus only on one area. Okay, so the first one is that it's like a Tesla electric vehicle skateboard design chassis. So mostly if you just see this chassis design of the electrical vehicle in Tesla, it will be like this only. Okay, so what is the innovation in this structure is that in future, if you're adding some battery, your vehicle will be like a Innova. Okay, if you're removing your batteries, it will be like a shifter. Just see how easy for you. If it is like a 7 passengers, you can add the battery. That's all. If you want to be like going with like a 2 passengers or like 4 passengers, you can reduce the size of the vehicle itself. Is it clear? This all like how in future days you will be seeing all these technologies. And this is also one of the structure where it is called as like a honeycomb structure, where we are just planning to implement in most of the vehicles already. They're planning to implement even in flights also. This is a place where they're implementing this place. It's called as like a honeycomb structure where it can take more impact. So electrical vehicles, it has to take more impact, right? Even IC engines, the engines will be placed in front side where it is taking more impact. But electrical vehicles compared with the IC engines, it can take more impact, but we have to focus on the materials also. Is it clear? And this is one of the structure which is called as trellis frame. Okay, it is like a this material. If you just see this material, it is called as like a bionic material. I think most of the biomedical or like biotechnology students they know about these materials. So we have to focus on the materials of the electrical vehicles also. Vehicle is fully made up of carbon fiber. Okay, so mostly carbon fiber. If you use some carbon fibers for the vehicle, the cost of the vehicle will be very very high. So guys, just try to focus on the materials of the vehicles also. Don't focus only on the motor or with the battery. Okay, everyone is doing on the same area. Just try to focus on other areas. So this is also nowadays the electrical bikes, right? Or even a bicycle. This frame structure, which is called as like a cantilever beam structure. Even many IC engines bikes like Java, they're using this structure. Okay, it's called as like a cantilever beam. So just try to focus on this area also.
भी नहीं मिलता है.
This is for IC engines. Try to make this research for the electrical bicycles or electrical bikes also, where it can save some weight. That is a very, very important thing. Okay, the final one, which is called as like a textile. So this is also like a multidisciplinary sector where many people are thinking that buying electrical vehicle is costly or buying Rolls Royce is very costly. It is not like that. The modifications or some of the materials which they're using in the Rolls Royce is very costly. So I think everyone knows that for making Rolls Royce, it will take even 6 months. And nowadays this Rolls Royce is comes in the even electrical sector. Okay, we have EV in the Rolls Royce. Okay, so if you just see this Rolls Royce, many people are thinking that the cost is because of the vehicle. Okay, that is one of the fact. But if you just see, even the upholstery means the materials which they are using in the Rolls Royce is very, very costly than the car. Is it clear? This or pure leather, which they make it from 7 different types of bulls, and that bull, okay, even one mosquito, if it bites that bull, it will get rejected. Is it clear, guys? So you have to make sure that just try to focus on the textile material of the electrical vehicles or even hybrid vehicles. That is also one of the latest area. You can see this vehicle, they're coated with gold. Okay, so if you just see this, the painting of the color vehicle is costly than the vehicle cost. Is it clear? So just try to focus on the some of the accessories for the electrical and the hybrid vehicles. Don't focus only on the motors. Okay, so this is also one of the latest materials which we are using for the electrical vehicles and even for the hybrid vehicles, which is called as like a carbon fiber. Okay, so this materials has a tendency of taking more impact. Okay, many electrical vehicles, if you see the carbon fiber, this material they're using in front. Many supercars also, if you see, they are using this material, the carbon fiber material. This material has a tendency of taking high impact because I told you right nowadays we are focusing on high speeds. So this is also one of the area where it is called as like a ventilated seats. So here what is happening is that it's not like a normal cars. Okay, the seating is not like a normal cars.
Names in the car tech biz. Here we go. Number names.
If you see the seats, okay, each seats is having some different technologies which is used here. And that means technology is same, but the thing is that we can able to set the temperature, different temperature for different seats. Don't think that is like a massaging seats like in Mercedes Benz. Okay, the material of the seats also is very costly, and if you just see inside that seats, it will be looking like this. Is it clear? So, for example, if any passenger is having some fever, for his seat it will be having different temperature. So this is called as like a ventilated seats. Nowadays we are using in most of the hybrid vehicles or even IC engines, even in electrical vehicles also they are going to use this technology.
Name.
Okay. So this is also one of the uh, material which they are using for racing. So this is called as like a Nomax. So this material nowadays they are using in racing. Okay, because everyone is afraid of electrical vehicle before, right? Because of the explosion. So this material, okay, it can withstand 11 seconds for like 1000 degrees Celsius. You can see here. So everyone thought that like the driver was died in the accident, but he came out of the fire accident because of this material. Okay, this material is called as like a Nomax. So if anyone is want to do some research, just to do some research in this type of area, which is like a multidisciplinary for the electrical vehicles, which is like a multidisciplinary for the hybrid vehicles. Is it clear? So what is will be the future technology? So everyone they're having some doubts, right, sir? I want to make a soul fuel, but what type of soul fuel I can use? So now, guys, please make a note of it. Most of the companies, you believe or not, they're focusing on this area, which is called as like a nuclear battery. Is it clear? It is called as like a nuclear battery, where if you it is like a uranium, okay, uranium which is like a coated by the diamond. So till now, are we using any nuclear battery? Is that yes, we are using some nuclear battery for the Voyager 1 and Voyager 2 and some of the rovers which we are using in Mars. Also, we are using the same technology. Is it clear? But the problem is that we can't be able to use it in a like a normal condition because even any human beings are there, the radiation will be very high. So because of this reason, okay, we are not using this technology in a normal places. Is it clear? So guys, everyone now they're focusing on nuclear battery. So just try to focus on the nuclear battery. Is it clear? So now this is like I will just take some 5 to 10 minutes. That's all. Okay. So this AI technology, because the topic is like AI with innovation. And before going for that, I will tell you what is the innovation because many people they have some doubts. What is the difference between like innovation and invention? So innovation is nothing but something already made, and we are just going to do some modification in that. Okay, that is called as like a innovation. Invention is something new. Okay, so this topics mostly what we are doing in colleges or companies is that we are just focusing on innovation. Nowadays, many people they're not going focusing on invention. Okay, it is like a reverse engineering. Many people we are just doing some modification. So if we say see here, the first one is the invention. The last one is called the innovation. Or like it will be just move on. This is also innovation. This is also innovation. This is also innovation. So innovation is just like a upgrading or something like technology which we are adding is called as like a innovation. So I think you will get some idea, right? So nowadays we are not doing any invention, guys. We are just focusing on innovation because invention means it is like something research. Is it clear? It is like a research. So AI technology, guys, don't afraid of AI technology. My advice is that always human intelligence is better than AI. But the problem is that AI is dominating in this time because of the Gen Z generation. Okay, Gen Z generation, okay, they're not bothering about anything. And then when we are recruiting for the companies also, they're not working properly. That is a main issue. So most of the people, they're focusing on AI. But everyone has to know that AI is very costly compared with the human intelligence, what we are using. Okay, humans are best, you believe or not. AI is very costly. But most of the company people, they're focusing on AI because mainly of this Gen Z generations. Okay, so how this AI is technology we are just splitting is that reactive, limited, and like a theory of mind and self-awareness. So AI is nothing but what we are giving, it will give the output, like a chatbot or some of the things. Okay. So where we are connecting this AI is that by the algorithms. I think everyone was knowing the Instagram like that, right? If you're just scrolling the videos in Instagram, and if you just stop it for 5 to 10 minutes, okay, the algorithm will know that you like that video, and again, it will be working with this algorithm, and you will get again and again the same type of videos. Is it clear? Is it clear, guys? So it all works with the algorithm. So AI is nothing but it will choose the right algorithm for that. Is it clear? And most of the AI, it will be having some self decision also it is taking. Even it have some corrections. For example, it can automatically correct also. It will be tuning itself. Okay. So this AI, without AI, you believe or not, in future it will be very, very difficult, guys. So I'm not telling you guys to learn the AI, but we have to know the AI. Without AI, in future it will be very, very difficult. And I'll just show how AI is using in our automobile because today the topic is like um, electrical and hybrid vehicles. Just see which places we are using this AI. If you just see the AI will see the vehicles like this only from the AI point of view. Okay, it will be just it is like a driver side. Okay, from the AI point of view, it will be seeing the vehicles like this only. It will be mentioning everything. It will be seeing everything. So the application of the AI in most of the automobile industry is driver assistance. You can see here if the vehicle is not having any technology, okay, if we manually if it is operated, it has a chance of accident here. But just see here because most of the human beings they're not bothering about right when they're crossing the roads or like that. In European nations they're very good, but in normal places they're not bothering. They won't see other vehicle is coming or not. And even electrical vehicle, the issue is that it is you don't have any noise. Is it clear? So here we have to focus on the area. So AI is dominating in this area already. Though it's like autonomous, as I already told you that it's like autopilot. So already I just informed about the Tesla, right? If you're feeling like a sleepy, okay, the vehicle automatically it will stop. Okay, after you're waking up only, or it will just intimate you, please take a cup of tea, and then we'll start the vehicles. Is it clear? And AI already just focusing on the cloud service. So it is automatically connected with the cloud. So guys, you have to know that cloud is one of the latest segments for the business. Okay, everyone we are connecting with the cloud. Okay, so we will know that what is happening in the like after like 1 kilometer or after like 3 kilometers, what is happening, everything you can predict before itself. And this is very, very important for your driving system. That means for the AI is giving all the inputs to you. That means it is assisting us. That is a very, very important thing. Okay, so even this is one of the very important thing. And you believe or not, everyone is buying nowadays some cars for 10 lakhs or 11 lakhs, right? In future, for example, after 5 to 6 years, everything will be automated. So you will get that same car, which is around like 3 lakhs or 2 lakhs. You believe or not? Okay, the cost of the vehicle will get reduced, and the manufacturing will be taking place for 24/7. There won't be any rest for the robots. Nowadays you can see that it is like 8 hours job, right? But in future, your full manufacturing sector will be like a robotics, and it will be operating and it will be controlled by AI only. So I'm not here to make you afraid that sir AI will be dominating like that. Already AI is dominated. Okay, AI is dominating in every field. So this is a very important things. Even I just informed already to Yelmali sir also. Even classes, most of the colleges till now we are running offline because AI technology. Many people they'll put mute and they'll sleep. Okay, we can't able to know. But if it is offline, we can able to know their eyes whether they're sleeping or whether they're interested or not. So in online technology, we can't able to judge them, right? So this is also drawbacks of the AI technologies. So we have advantage and we have some disadvantages. Okay, this is also the driver monitoring system. Also nowadays, AI is dominating. Okay, it is monitoring each and every time. You believe or not? Okay, it will be detecting your eyes, everything. It will be monitoring. Even your vehicle. Okay, the AI will be monitoring each and every segment. Okay, whether any cat is coming or like any persons are crossing, how many vehicles are coming, everything it will be just focusing. So that is why AI technology is like one of the dominating area. So guys, we have to know what is happening. That is a very very important thing for upgrading. Okay, and because of this AI technology, it's like even emotion detection also nowadays is available. So many people they're causing accident when they're very happy or when they're feeling sad. So AI will detect now that whether this guy is very happy, the vehicle automatically slow down. Okay, when he is not feeling good also the vehicle automatically it will control. So now the emotion sensor also is available. Emotion detection also is available in vehicles. So you have to be very normal. Then only your vehicle also will be traveling very normally. Is it clear? Because this is the area of like a risk detections. So even testing. Nowadays AI is used for testing the vehicles also. Uh, so these things all is all like a future automotive. So in after like 2030, everything will be automated, guys. So why we are conducting this FDP is that you have to know this. FDP is like a faculty development program. Is that faculties has to upgrade. So that is why like many people they're conducting this type of faculty development programs. So faculties we have to upgrade. Otherwise, AI will dominate. That's all. Very simple. Okay. So with this, like I wind up my session. So 2030, I'm telling you that AI will be like in another level. Okay, it will be just dominating everything. So with this, I'm just winding up my session. So any doubts? So any doubts, you can just
Participant, if you have any doubt, you can ask. You can
and one
unmute
more
that
thing,
mic
guys.
and you can ask.
Yeah, and one more thing, guys. If you want to connect me in LinkedIn, my LinkedIn profile name is Dr. Prabhakar Segar. Okay, you can connect me in LinkedIn also. And thank you once again, Dr. Elumalai sir, for giving me this opportunity.
Sir, thank you, sir. Thank you so much.
A very good evening and a warm welcome, respected dignitaries, esteemed guests, faculty members, and dear participants. Myself, Dr. Ujjwal Kiran, Assistant Professor, Department of Mechanical Engineering. It gives me immense pleasure to welcome you all to the closing ceremony of the AICTE Atal sponsored 1 week online Atal FDP on AI powered optimization strategies for sustainable electric and fuel cell vehicles, organized by Department of Mechanical Engineering, Aditya University. Over the past 6 days, we have gathered in a virtual space to explore, learn, and share ideas that will help shape us into thoughtful researchers, educators, and innovators. Now, without any delay, I would start today's event by welcoming in a virtual mode our dignitaries. It is my distinct honor to invite Dr. M. Srinivas Reddy sir, Deputy Pro Chancellor, Aditya University. He already joined an online meeting. We welcome you, sir.
Yeah, thank you.
It is my warmest welcome to Dr. A. Ramesh sir, Pro Vice Chancellor, Engineering and Sciences. We welcome you, sir. And it is my distinct honor to invite Dr. SDDV Bhimeswara Reddy, Head of the Department, Mechanical Engineering, to join us. We welcome you, sir. To give us a comprehensive overview of the topics covered and the milestones achieved, I invite Dr. SDDV Bhimeswara Reddy, co-coordinator and head of the department, to present the summary of FDP.
Thank you, Ujjwal sir. Respected dignitaries, Deputy Pro Chancellor M. Srinivas Reddy garu and Dr. A. Ramesh sir, Pro Vice Chancellor Engineering and Sciences, and my dear participants, esteemed resource persons, dear colleagues and participants. On behalf of the Department of Mechanical Engineering, Aditya University, I extend my sincere and heartfelt thanks to AICTE Atal Academy for sponsoring and supporting the 6-day online faculty development program on AI powered optimization strategies for sustainable electric and fuel cell vehicles. I express my deep gratitude to all the eminent resource persons from the first day to last day from reputed institutions and industries who shared their valuable knowledge, insights, and experiences. Their expert lectures have significantly enriched the participants' understanding of emerging trends in sustainable mobility, artificial intelligence, energy storage, and fuel cell technologies. I would like to place on record my special appreciation to our faculty coordinator, Dr. Ilumalai, who have done excellent background and planning work for his program. As you all know very well, he is a dedicated and academician and a good researcher, and his commitment, coordination, and scholarly approach played a crucial role in this successful exhibition of this FDP. This FDP witnessed an overwhelming response with 766 registrations, out of which are 450 to 480 participants actively attended in this section, reflecting the relevance, quality, and impact of the program. I would like to convey my special appreciation to our honorable management, Deputy Pro Chancellor sir for supporting us, and Dr. A. Ramesh sir for encouraging, and Vice Chancellor sir, Pro Vice Chancellor sir, and Registrar and Dean for their continuous encouragement and unwavering support, which made this program a great success. And my sincere thanks to the Atal FDP coordinators, organizing committee members, and the supporting staff for their dedicating efforts, meticulous planning, and smooth execution of all the sessions. I also thank all the participants for their enthusiastic involvement, active interaction, and commitment throughout the program. Once again, I extend my gratitude to everyone who directly or indirectly contributed to the successful completion of this FDP. I am confident that the knowledge gained through this program will greatly benefit teaching, research, and professional development. Thank you. Thank you, one and all.
We are now privileged to hear from our distinguished dignitaries whose unwavering support and vision have been instrumental in making this program success. Now I request Dr. A. Saravanan, Dean, Research and Consultancy, to address the participants.
Thank you, Ujjwal sir. Respected Deputy Pro Chancellor M. Srinivas Reddy sir, Pro Vice Chancellor Engineering and Science Dr. A. Ramesh sir, Head of the Department Mechanical Engineering Dr. Bhimesh Reddy sir, faculty member, and my dear participants. Warm good evening to everyone. As we come to the end of this 6-day faculty development program on AI programmed optimized strategies for sustainable electrical and fuel cell vehicles, I would like to thank everyone of their active participation and support. A special thanks to our 13 expert members for sharing their valuable knowledge and insights. Their contribution made this program very meaningful and inspiring. Actually, more than 700 participants, it is not a simple thing. Out of that, nearly 500 participants actively participated. So that is meaning that importance of the topic. This AI powered optimization strategy for sustainable energy, electrical and fuel cell vehicle. To all the participants, I hope you found the session useful. and that the knowledge gain will help you in teaching, research, and the professional growth. I also appreciate the Department of Mechanical Engineering, especially the organizer Dr. P.V. Elumalai, for making this event a success. Wishing you all the best for your future. Thank you very much. Thank you, sir.
Thank you, sir. Thank you so much. Now I request Dr. A. Ramesh, sir, Pro Vice Chancellor, Engineering and Sciences, to address the participants.
Thank you. Thank you,
Yes,
Vasual.
yes, sir. Now it's on.
And respected dignitaries and resource persons and esteemed colleagues and dear participants. As we come to the closure of this faculty development program, I would like to express my heartfelt gratitude to everyone who made this event meaningful and successful. For the last 5 days, this FDP has truly been a platform for learning, collaboration, and professional growth. The insightful sessions delivered by our distinguished resource persons have enriched our knowledge, broadened our respective perspectiveness, and inspired us to innovate practice in teaching, research, and academic administration. So I sincerely thank our management for providing a great platform to our faculty, not only inside the faculty and the external faculty members also got a great experience in experience in learning this 5 day FDP. My special appreciation goes to the coordinators and organizing team for their dedicated efforts in planning and executing this program so smoothly. And I also appreciate the participants of their active involvement and interest and commitment throughout the program. And I am confident that knowledge and skill gained here will be effectively translated to our classrooms and research endeavors. And with this, I will once again thank all the active involved. I thank all the members who are actively participated in this particular wonderful event. And I request each and every one of you please share the knowledge what you gained during these 5 days in your classrooms. Okay. Once again, I thank all the coordinators for making this event in our campus, and I wish you continued success in your academic journey. Thank you very much for giving me this opportunity.
Thank you, sir. Thank you so much for your kind words. You'll always be supporting and encouraging all the faculty members. Thank you once again, sir. Now I request Dr. M. Srinivas Reddy, sir, Deputy Pro Chancellor, to address the participants.
Yeah, thank you, Ujjwal. So, first of all, I congratulate all the members in the Department of Mechanical Engineering for successfully conducting this Atal FDP in our campus, especially HOD Bimesh Reddy and the coordinators Elumalai and Ujjwal and all other people for their active involvement. So these type of FDPs are very much useful for staff members to enhance their knowledge, because if you participate in these type of FTPs, then only you can gain the latest technologies, what is coming up and what is required to teach to the students. So you can have all those ideas. Then only you can enhance your teaching skills in the classroom. Otherwise, it is very difficult for you to grab the attention of the students. Nowadays, students are not that much attentive, and within 10 to 15 minutes, they are distracting from that classroom teaching. So, if you want to attract the students and if you want to engage the students for 1 full hour, it is very much essential to have a better and latest knowledge compared with the student, and uh, then only you can grab the attention of the students. So that's why at least attending one FDP in every semester is required for each and every staff members. Because of that only we are made it compulsory for all our staff members to attend at least one FDP in a year. In the coming days, we make it to once in a 6 months also. And these AICTE Atal FDPs are very much useful. This is the sixth Atal FDP we are conducting in this academic year in our campus. So I appreciate all the people for successfully conducting on all these FDPs. The registrations and the participation every day is very much appreciable. So more than 600 registrations were done as per the information given by the HOD, and every day more than 400 people are attending. So it is a grand success. So I hope in the coming days also these type of FDPs, more FDPs will be conducted in the department, and it will be beneficial to more number of people. So thank you very much for giving this opportunity. Thank you.
Thank you, sir. Thank you so much, sir. Thank you for your valuable words. Your encouragement and vision are a source of motivation for all of us, sir. Thank you. Now I'm handing over this session to Anusha madam to continue the session.
Thank you, Dr. Ujjwal. Good evening to respected dignitaries. This program would not have been complete without the active participation and enthusiasm of our learners. Now it's time to hear from you. I invite few participants to switch on your video and to provide their valuable feedback and experience. Dear participants, please provide valuable feedback.
Yes, good evening.
Sir, good evening,
Yes,
sir.
sir. Good
Yes,
evening,
sir.
sir. You can
Good
proceed,
evening,
sir.
sir. You carry on.
Yes, I am Dr. M. Parthasarathy, Professor of Physics at Wales University, Pallavaram, Chennai. It is my honor to share my feedback on the Atal Online FDP program. That means the titled AI-powered optimization strategies for sustainable electric and fuel cell vehicles, which was conducted by the Department of Mechanical Engineering, Aditya University, for the past 6 days. First of all, I express my sincere thanks to the head of the Department Mechanical Engineering, Atal FTP coordinators, organizers, team members, and the senior officials of the Aditya University for participating in the fantastic 6-day online FDP program. Really, it was an exceptionally insightful and enriching experience for all the participants. The program offered a comprehensive blend of theoretical foundations and also practical applications, highlighting how artificial intelligence can be strategically leveraged to optimize performance, energy management, and sustainability, particularly sustainability areas in electric and fuel cell vehicle systems. From the day one to till now, all the sessions were meticulously organized and systematically well organized. All information has been delivered by the knowledgeable persons from various reputed higher education institutions and private R&D centers across India, who have been effectively explained interesting information topics such as something like a predictive modeling, machine learning, algorithms, real-time optimization techniques relevant to the vehicle electrification, and the very important hydrogen technologies. In the day one, Professor Saidur Rahman is a distinguished research professor from Sunway University, Malaysia, has given a talk on the exploring low-cost advanced materials in longer duration energy storage in the field of mixing. It was a fantastic session. And also in the next, the few things, Mr. Satyanandan Mahadevan is a vice president and head power solution business system in the topic of next generation sustainable vehicles for CO2 reduction is a wonderful explanation throughout the session. And also, Dr. T. Karthikeyan Sharma from NIT Andhra Pradesh has delivered a fantastic application-oriented AI in the energy storage in the future also. Dr. Sridhar, professor from BITS Pilani, is addressing a global warming across the world through the carbon nature. M. Parthasarathi, manager R&D department, that is Shankar Advanced Mobility Solutions, is explained a fantastic hydrogen technology sustainable for the future generations. Dr. S. Prabhakar, director and BTI Ignite Incubation Council, has explained the green and hydrogen energy and the sustainable solution for the intelligence transport system, and also the brain to vehicle concept, brain to health, automatic active health monitoring. That is so many interesting informations have been carried out, and they're really very useful for the participants like us. And also the interactive sessions were effective in bridging the gap between the academic concepts and also the real world challenge. At every stage of the FTP, Professor Dr. Yelmali, the AICT coordinator, and his entire team guided the participants through the WhatsApp mode and also Atal online examination, and finally addressed all the difficulties whichever they issued by the members, and finally they received their certificates also. Overall, the FDP significantly broadened my and also all the participants' perspective on the role of AI in the advancing sustainable transportation technology, and I found to be highly beneficial for both research and professional development. Once again, I thank the convener, Dr. Yelmalai, and the officials of Aditya University for conducting the wonderful FDP. Thank you all for giving the opportunity. Thank you, sir.
Thank you, sir. Thank you for your kind words and constructive feedback. I request any of the participants, to provide your valuable feedback.
Good evening.
Good evening, sir.
First of all, I'm very happy to share this feedback for this FDP, because the FDP was an excellent and enriching learn that is providing a enriching learning experience, offering a well-structured sections delivered by highly knowledgeable and experienced resource persons. So here the discussions on AI-driven optimization, electric and fuel cell vehicle technologies, and sustainable mobility were insightful and practically oriented, highly relevant to current research and industry needs, as well as the our environmental needs also. The most of the things they discussed about the sustainable mobility, that is very important for the uh, current future trends. So I sincerely appreciate the organizing team for their outstanding planning, coordination, and commitment in conducting the program smoothly and professionally. Their efforts in bringing together eminent experts, maintaining the high academic standards, and creating an interactive learning environment are truly comfortable. So overall, the FDP was highly informative, motivating, and valuable for enriching both technical knowledge as well as the research perspectives. So I thank the team for offering this wonderful FTP to gain the more research knowledge as well as the teaching knowledge. Thank you, thank you, thank you.
Thank you, sir. Thank you for coming forward and providing your valuable feedback.
So, good evening, all.
Good evening, sir. Yes, you can
This is
carry.
Dr. Pavan Sarone, Associate Professor, presently working at JSPM Rajeshi Shahu College of Engineering, Tathawade, Pune. So I would like to appreciate all the coordinators, Aditya University, for organizing such wonderful event. As if we see the as this has really given the opportunity to interact with very highly knowledgeable as well as very expert resource persons, just like in session one was amazing, that was headed by Dr. Saidur Rahman sir. So my domain was the material, so it was really wonderful session, and it gives us the different idea in which that how the materials progress is moving, then how the magazine material was manufactured, how it is to be done, and what are the research avenues related with the material. So it was very wonderful session. Secondly, the timing of the FDP was it was organized in the evening schedule, so that was really different, because as we know we are all the working faculty, so at the college timings or the day timing it is really difficult, but this planning was really wonderful, and almost most of the faculties have benefited from this. So along with this, the topic or the selection of the topic or FDP is also amazing, because if we see it has given the strong exposure to the machine learning as well as some AI based optimization techniques also. So there is a lot we learn from this FDP, and I think really the credit goes to all the coordinators, all the organizers. So for me or for all the participants, it seems to be overall the well organized, interactive, and academically enriching FDP. So thank you all for giving me this opportunity. Thanks once again.
Thank you, Dr. Pavin. Thank you for your valuable feedback.
Good evening. I'm Dr. Janorish.
Good evening, sir.
I'm from working as an associate professor and deputy controller of examination. I'm working in Dayanand Sagar College of Engineering, Bangalore. Basically, I'm from automobile department. I found this FDP is more connected to my research. I do research on autonomous and self-driving cars, especially the sessions on AI-based electric and hybrid vehicles, and also the fuel cell technology by experts from Ashok Leland and from various organizations was really fantastic to connect and to gain more insight about what happening in the future trends in automotive systems. I congratulate all the entire organizing team for such a wonderful event which was conducted by Aditya University. One thing I want to highlight here, in this entire FTB, they have allocated for every 20 participants, even the participant members were more. For every 20-25 participant, I guess, they have allocated one faculty to address the queries. That was fantastic, which is organized by the team. So we were very, systematically, and it was very systematic, and it was very easy for us to address our queries to the respective faculties. Hats off for the team, Aditya University and the organizing committee for well organized this event. So in future, definitely will be get connected, associated with such event with your university. Thank you for that.
Yeah, good evening, ma'am.
Good evening, ma'am.
Yeah, good evening, ma'am. This is myself, Sahiti, Dr. Sahiti. I am from VNR Vigyan Jyoti, Hyderabad. I belongs to Mechanical Engineering Department. First of all, I just want to thank the organizers for conducting such a nice FDP. Generally, I mean, when the participants are very huge, they generally face problems. But here, we have not faced any problem because they maintained faculty participants ratio properly. Who we had a WhatsApp group, whatever the doubts we had, easily whenever we post a doubt, quickly we got the response. We can even call them if we have any problem. That is very they maintained it very nicely. And one more thing is this FDP is in the evening session, so easily we can attend the sessions without missing our classwork and regular activities. That is one good thing about the FDP. And one more thing, the speakers, they're very knowledgeable. They have given us very valuable insights and their expertise and practical applications where we can use all these things. They have given very nice information. And as we all know, as a faculty members, in this AI era, students are going very fast and they are learning very quickly. So we have to update ourselves, otherwise we won't match their expectations. So once again, I thank Atal Portal, AICT Atal, also for giving us this opportunity to attend such a nice programs. And with this, once again, I thank Aditya University Mechanical Engineering Department for conducting such a nice FDP, and also Atal for giving us this wonderful opportunity to learn something. Thank you very much.
Thank you, ma'am. Thank you for providing your valuable feedback. And this is all because of our coordinators' planning and consistent follow up, ma'am. And we have organized this team, this Atal FDP successfully, ma'am. And I request Prakash sir to provide your valuable feedback.
Good evening, ma'am. Good evening, all. This is Prakash from Rajalakshmi Engineering College, Chennai. Informative interactions from the eminent guest speakers like Dr. M. Parthasarathi, Dr. S. Prabhagar, Dr. R. Subramaniam. I thank the coordinators, Dr. Bhimeshwari Reddy sir and Dr. P.V. Elumale. They have coordinated around 500 participants. They spend a lot of time over these past 6 days. Thank you.
Thank you, sir. Any interested participant to provide your valuable feedback? Sir, Dr. Elumale, sir.
Hello.
Shall we? Yes, sir. Yes.
Good evening, ma'am.
Good
I am
evening.
Dr. D.M. Mate from Rajeshri College of Engineering, Pune. The entire session, starting with the day one with Rahman sir and till today in the afternoon, it was really wonderful sessions. We got so many informative sessions, and that enriched our knowledge also. Even so many best part for your FDPs, like the timing. As one of the participant from our college, he said the timing was fantastic. Then regarding the feedback, every time I have attended all the sessions, but then also sometimes I miss. I got the feedback link from the chat box and in WhatsApp also. So other people are not doing that. That is again best part. Third is that all the sessions were fantastically organized. Thanks to Elimalai sir for wonderful organization of this FDP. I thanks to Aditya University, and if in future if they organize or if you organize any workshop, we will definitely join the sessions. Okay, thank you, sir. Thank you, ma'am.
Thank you, sir. Thank you for providing your valuable insights. Sir, Dr. Elumalai, sir.
Madam will
Ma'am,
move from.
ma'am, I am Dr. N. Tamil Selvan from Sri Satyam College of Engineering Technology, Tamil Nadu. Ma'am, really last 1 week from 21st to till date, I am very interested to attend these all sessions. Each and every sessions very much useful for the for us and to all. Definitely, I will share the information to my colleagues and my students. Thank you for giving this wonderful opportunity. And also, I thanks to each and every coordinator for this faculty development program, especially Elumalai sir, and and also I thanks to all coordinated from Aditya University, Department of Mechanical Engineering. Thank you, sir. Thank you.
Thank you, sir. Definitely, your insights and undoubtedly
Hello?
your valuable. Yes, sir.
Yes, my
May
name
know.
is Dhanasekaran, ma'am. So
Yes.
Dhanasekaran Adiyaman College of Engineering also.
Yes, sir. Yes.
Ma'am, last week you given the FDP very good, ma'am. So, the resource person also given the good lecture, ma'am. Thank you, ma'am. Thanks for Elumalai, sir, ma'am.
Welcome, sir.
Network is,
Thank
ma'am,
you.
also.
Okay, sir. No issue. No issue. Thank you, sir.
Thank
Thank you for providing your valuable feedback.
Alisha madam will go for what are things.
Yes, sir. Yes, sir. As the curtain falls on this remarkable FDP, it is a time to acknowledge and thank everyone who made this journey possible. On behalf of organizing team, I extend our sincere thanks to all the dignitaries, esteemed guests and participants who have graced us with their presence today. First and foremost, I would like to thank our esteemed resource persons for taking time out of their busy schedules to join us and share their valuable knowledge. Your insights will surely guide and inspire us throughout this program. Your efforts making complex topics accessible and interactive are deeply appreciated. I extend my sincere appreciation to our organizing committee, coordinators, and technical team whose hard work behind the scenes ensured the smooth execution of this FDP. Your dedication and commitment made this event successful. To our esteemed faculty participants, thank you for your active involvement, curiosity, and enthusiasm. Your engagement has made this FDP a meaningful learning experience. We express our gratitude to our management for their constant support and encouragement in fostering academic growth and innovation. Once again, I thank all for being a part of AICT sponsored 1 week online Atal FDP on AI powered optimization strategies for sustainable electric and fuel cell vehicles. We look forward to more such opportunities for learning and collaboration. Wishing you all a continued success. Now I request Dr. P.V. Elumalai sir to play national anthem. Let us
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
With this, we officially conclude the closing ceremony. Jai Hind.